Welcome, everyone. Happy Friday or happy Saturday morning. Today we're continuing with the Nim Manual. This will be probably the last live stream for me reading manual. We're gonna take a short break from it because it seems like we could use a break to do some other stuff in the meantime. Maybe try to use that knowledge in some way rather than just keep reading. But for sure, we're gonna return to it after the stream at some point. Maybe 1 or 2 streams break or something. No big deal. That's pretty much it. So yeah, let's just get to it and let's start reading. Hopefully today I will be a little bit more lively than last time, because last time I don't know, couldn't focus. Alrighty, so let's lift off where we stopped, which is type relations. The following section defines several relations on types that are needed to describe the type checking done by the compiler. Okay, so we're gonna learn about types and how they work. So we had type equality. Nim uses structural type equivalence for most types. So that's where it differs from many other things. It's structural type equivalence, which could be partially compared to what TypeScript does, which is like duck typing, but not really. Only for objects, enumerations, and distinct types, and for generic types, name equivalence is used. Okay, so basically our undefined objects, enumerations, and all that, anything distinct, and generic types, which could be combined, I guess, with a bunch of them, are used for name equivalence. Okay, so yeah, somewhere between those two approaches. Tuples are, for example, exactly like in TypeScript. If types of elements inside match, they're the same. All right, so subtype relation. If object A inherits from B, A is a subtype of B. Okay, so basically, instead of saying that this object inherits from something, we basically say that A is a subtype of B. Okay, I like the word subtype. It's just, already instantly tells you like, okay, this is the more specific thing. This subtype relation is extended to the types var, ref, and pointer. So all mutable references and pointers can also be, considered subtypes. Okay. If A is a subtype of B and A and B are object types, then okay, so yeah, whatever modifier you put in front of it, it's still a subtype of the same thing with a modifier. So basically, this makes it possible for us to kind of comprehend it and work with it easily. Makes sense? Note, one of the above pointer indirections is required for assignment from a subtype to its parent type to prevent object slicing. I am not familiar with object slicing, but it doesn't sound good. Convertible relation. A type A is implicitly convertible to type B if the following algorithm returns true. There we go. Somebody can submit probably a little issue to GitHub to get a little F removed. So type A is implicitly convertible to type B. Implicitly. If the following algorithm returns true. Oh, okay. So by implicitly convertible, what it means is that the type conversion happens behind the scenes. We don't write our code like, hey, I want you to convert to this type. It just happens behind the scenes, seamlessly. So in what situation does does it happen? If it's a subtype A of B, I guess. So if it's a subtype, it's just gonna fit somewhere, right? So it is implicitly convertible from A to B, I presume. So if A is a subtype, it will fit into B. Okay. Other than that, if it's integer literal and B is inside those literals, okay, and then additionally, oh wow. So basically, depending on which integer it is, fits in various. Okay, so basically, I guess a smaller. Because normal int can be implicitly converted into either 32 or 64 version of it. And 8 will fit into anything larger, and 16 into anything larger, this into anything larger. Okay. The same for the unsigned. That's what EU standard for. Unsigned. Hello, Taras. How are you doing? I hope you are doing good today. And the same thing goes for floats. Although, no, look at that. We can interchange floats both direction. Interesting. And for sequences, probably we want to make sure that those base types of A and B are compatible. Something with C strings that fit into pointers and strings that fit into C strings. All that fancy stuff. Okay, so we use the predicate type equals for the type equality property, and the predicate is subtype AB. For the subtype relation, compatible parameters and effects AB is currently not specified. Implicit conversions are also performed for Nim's arrange type construction. Let A0 be 0 of type T. Let A, so basically we are given type F, the formal parameter type, then in an implicit conversion from A to F exists if A is larger or equal to the smallest of F and B0 is less or equal to the highest of F. Okay, so basically if this range is within some kind of specific type, like, this is from 5 to 30, it'll fit in something like int 8 because it's from 0 to 255. Taz is saying, doing good, updating my BF sheets. I have reduced amount of recalculations and added cycle dependency detection. That's awesome. I added cycle dependency detection today as well, but to something else. Yeah, I'm slowly learning more about SerialDB, and the thing that I'm kind of making is a simple inventory management kind of software. Right now I'm just working on a database, but what it allows is basically you can have an item, any kind of item, I don't know, a phone, a keyboard, a cabinet, something, right? And an item can be either a normal item or it can be marked as a container. And if it's a container, that means that, some other item can be inside of it. So I have it basically where you can have a list of items, and then you have relations that says, item A is located in item B, okay? And therefore, I can then say, you know what, I'm searching for example, some specific bolt of some specific size and what. I can search through the database and then see that, oh, this bolt is inside this box, that's inside this organizer, that's inside that specific cabinet shelf in that specific cabinet in, for example, workshop. And because I have this whole chain of relations, what's inside what. And the thing is that I needed to add detection so that when I'm specifying those relations between things, I don't have any circular dependencies. So basically for each relation kind of has pre-computed list of all the parents, like the chain up. And if when specifying new relation, it recalculates, because I have the database actually recalculate everything for the recursive tree. So if it will find that at the end, the list of parents for the box will start having something repeating, duplicate of anything, that means that, oh, wait, we have circular dependency, abort transaction. So yeah, that I hope it works. I mean, I can probably share it. Yeah, let's try that. I'll get back to Nim in a second. Whoever's here for Nim, you can probably skip 5 minutes ahead. Alrighty, so if I go to Explorer, you can see that I have a bunch of items, right? I just added a bunch of items, like, let's say we have a desk, okay? It's a container because you can put stuff on a desk, right? You should write tests for SQL. I will. Ignore package, whatever. We have total. The only thing that's manual specified is the unit. Unit X is basically how many of something I have, and a quantity and universal quantity, they're all automatically calculated, okay? So I could say, let's focus on the desk, okay? I could go to write a query that I want the item desk to be located in, wait, no, let's make a new item. Create item banana, okay? Set, what do I need to set for those items? I don't remember. If it's container, a name, and unit. So it will be is container false, right? The name, a banana. And then we have unit, which will be, let's say I have a banana, and I will count bananas in pounds, okay? Container. Oh, I need to use equals here. Sorry. So let's say I want to count bananas in pounds, okay? So I'm gonna say that I have unit will be unit pound, okay? And I should be able to just define it. Bam. For your total, oh wait, total dot unit is, because that's nested. There we go. Bam. So got banana, quantity 0, because we don't have we have a definition of a banana, but we don't have an amount located anywhere. So I want you to say that the item banana is located in item desk, and I have, for example, 2.5 kilograms of a banana, okay? Bam. Now if I'm gonna go to select everything from item banana, there we go. We have 5.5 pounds, which is an universal unit. Universal unit for weight is grams, so we have 2,500 grams. And that calculates itself automatically. If I would place banana, because there's nothing stopping me from just putting it inside Office, where I have, let's say, 250 pounds of it, for example. Bam. Now we have total of 255 pounds, because banana is in 2 locations, right? Select this, and whatever's coming from banana located at, right? Yeah, as locations. I can do that, and I can see that I have located in, sorry. So I have the banana located there, right? In 2 spots. That's the magic of it. But the fun thing about this whole thing is that I can say that I have a box, okay? Box 1. It's a container. I'll just call it box 1. And containers, they have to be just one. You can't have it multiples of a container. You just have to create them as separate objects. Bam. Then I'm gonna create a box 2. Okay. Bam. So I should be able to say, and let's say box 3, because I want to try to nest them. I actually haven't tested that functionality. So we have 3 boxes. So now I can say that item box 1. Let's say the box 2 is inside box 1. And quantity will be 1, because that's all it can be. Bam. We have it located. I can locate box 3 inside of box 2. Bam. Now, can I locate box 1 inside box 3? No. Circular reference detected. Box item was already present in the location array. So it works. But nothing is stopping me from putting that box 1 inside, for example, the desk. Okay? I'm gonna run it. And now I can basically ask, where is it located at, okay? So I can say that, give me all the locations for, I don't know, box 3. I want to know where that box is, but let's look at it in dot location strings. And that should make it a little prettier. We can see that it's in my office, inside the desk, inside the box 2. Just like that. Automatically, when created, and you know, I can say, you know what, we're gonna ask that about the box 3 in a second again, but I'm gonna do actually delete that specific relation. Instead of querying for it, I'm just gonna search for it, located in, and that was the box 1, right? So n is item box 1. So that was this relation. Let me just copy its ID. And we're gonna delete this relation. Okay. Now when I search where the box 3 is, hey, box 3 is inside of box 2, which is inside of box. Well, box is not anymore in the office and whatnot. And you know, I could plop it anywhere I want. It basically recalculates the tree, even if I would, for example, let's put it back inside of the desk. Boop. Now it's not inside of the desk. Let's rename my office to office. It will be update item office, where set name is office, exclamation mark. All right. Gonna run it. And now I'm gonna check the location. There we go. Update it. So if we're gonna go into that specific location of the box 3, okay, this is location, you can see that it already has pre-calculated location, item office, item desk, and a string representation. So when I will be querying it, I can just give me the strings, which are names, and I can print them out nicely as little, you know, clickable things where I already have a name. I don't have to fetch the name every time I have something. Yeah, that's that. And manager just calculates amounts and whatnot. And now I'll be adding a functionality where I can specify that I have a set of things, like a box of bolts I bought, for example, and the box of bolts has 100 bolts, has 100 washers, 200 washers, and 100 nuts. And it will automatically, and I can say that, you know what, I have 10 of those boxes unopened in that cabinet. while the specific bolt, maybe I have that location and that other location unpacked, and I can search, hey, how many bolts do I have? Where are they? And it will tell me, okay, you have some of them in this organizer, some here in this drawer, and you also have 1000 bolts packaged in those boxes, as, unopened, and that sort of thing. So, and I'll be adding temporarily moves where you can just grab a few things like a tool or something, take it, and then in an app on the phone you would be able to just see what you just moved. Oh, there's that item I just moved. Where should I put it back? It says there. Okay, you just press a button and it's put back. But if you're looking for something and you can't find it, it will just tell you, hey, you remember you also put that, move that there temporarily or something. So that's the thing that I'm trying to build for fun, for myself. I don't know, I kind of always dreamed about that kind of inventory system. And on top of that, the whole thing that I can attach like chunks of data to various items, because for resistors, I would like to, and other electronic components, I want to have specific parameters that I'm looking through. While maybe for many things I want to have color, for other things I want to have some additional dimensions and all those things, and I would like to be able to basically search through them, but I don't want to have to specify or scroll through the endless list of all the possible configurations every time, and I want to be able to add further configurations or whatever in the future, not through the database, but database just stores them generically or something. I don't know. I'm just playing those ideas. It's fun. And SurDB actually lets me do that, so I'm very excited. All right, getting back to Nim. So we know that we can basically convert ranges to some more broad types implicitly. But for explicitly, a type A is explicitly convertible to type B if the following algorithm returns true. Another double F. And we have another algorithm. If it's explicitly convertible. If it's implicitly convertible, is also explicitly. You can just explicitly say, hey, I'm converting you to that type. Additionally, if type equals, if it's equal type, then true. If it's distinctive, if basically, if it's a base of a distinctive type, you can, you can basically convert between types that have the same distinctive type. Okay. So, I explicitly define dollars as something that takes from float, and maybe the same for euro. I can explicitly, if I really want to force it, I can just force conversion and it will work because they both share the same type, which is the float. Okay. Is integral type? Integral is any kind of ordinal type, or the kind that fits into what? Don't understand that part. T.kind. And pointer type. Not sure. If it's integral type, and then also if it's subtype A of B or B or of A, you can convert between them explicitly as well. All right. The convertible relation can be relaxed by a user-defined type converter. Okay. Oh, so you can define your own converter to integer, where you basically give it a character. Okay, and it returns an int. And that basically says result is ordinal of x. Okay. So that means that I can suddenly implicitly convert from the character to integer. So I tried to do this. It found like, you know what? I have converter available from character to integer. This looks like a perfect fit for it, and it works. Okay, and you can still use it explicitly if you really want to, because you know it's gonna happen implicitly, but maybe you want to just highlight the fact that it happens in this specific case. Awesome. I'll probably use it at some point in my life. Tara says, you have so much energy talking on Friday evening. I'm barely sitting. Yeah. Somehow I'm all right now, which is awesome because last Friday I was having trouble, but hey, this is exciting time of day for me. I'm a night owl. I'm probably like you in the morning. I can barely get up in the morning, and something like 11 a.m. is still morning for me. Yeah. Okay. So the type conversion TA is an L value. Okay. If A is an L value and type equals or distinct T of type A holds. Wasn't L value the reference type? Yeah, basically reference types follow probably similar thing. I'm not gonna decipher that. I don't think it really matters in our case. So far, things with type conversions were somewhat easy to understand, let's say. So did you have Good Friday, Taras, or was it kind of meh Friday? Assignment compatibility. An expression B can be assigned to an expression A. If A, again, the IFF, what the heck is going on? An expression B can be assigned to an expression A if A is an L value and is implicitly convertible B to A. Holds. For expressions, I'm not gonna try to understand that. That says, whole week sucked. Oh, have I told you about developer using AI in our team? You were mentioning that somebody was using AI and they were just reintroducing bugs, which wasn't fun. That sucks for your team and for the developer. Overload resolution. In a call P arguments, the routine P that matches best is selected. Okay. So overloads mean that, we have multiple, for example, multiple procedures with the same name, but with maybe different parameters or arguments. So when we're calling that procedure P, given the arguments, the routine P that matches best is selected. But what does the best mean here? If multiple routines match equally well, the ambiguity is reported during semantic analysis. Okay. Tara says, I'm the only person reviewing PRs for some reason. Oh, that's fun. And that developer said my manager that my reviews are too strict. In other words, I'm stopping him from pushing shitload of AI-generated shitcode. He is lucky I can't meet him in person. Yeah. I had few situations where actually I was the person that I was in a very small team of 3 developers, and I was like the only one that said, you know what, let's have the concept of PRs because we could really use it, because I already saw that there was lots of very questionable code being pushed, and I'm a person that kind of likes standards, likes to keep things clean. Maybe it's not as apparent in live streams because I'm trying to do things somewhat fast to, move forward within the, short period of 4 hours or something. But, when working on something larger, you want to keep things in order or some consistent. So I was pushing towards those PRs, and it just felt weird that, I'm trying to correct my superior, like, hey, maybe we can format it in this way, or how about we name it something other than A1 or something of that sort, yeah. So yeah, and the thing with going through AI code is it looks very convincing, right? It looks very convincing. Then you start reading, it's like, oh, I see the faulty train of thought. Like it's probably latched on something and started going way off until it barely made the thing that was supposed to work. So, if multiple routines match equally well, the ambiguity is reported during semantic analysis. So basically, we have multiple procedures, and the language basically can't figure out which of them kind of fits better the situation. It's gonna say, you know what, this is too ambiguous. You need to do better as a programmer. Every argument and arguments need to match. Okay. There are multiple different categories how an argument can match. Let F be the formal parameter's type, and A the type of the argument. Formal parameter type, and A will be the type of the argument. So I guess F is what type we defined, while A is what we actually passed. So we can have exact match. Both A and F are of the same type. Okay, then that means we have exact match. Literal match. Exact versus literal. A is an integer literal of value V, and F is a signed or unsigned integer type, and V is in F's range. Okay, so V would basically, the value of A would fit inside F, or A is a floating point number and again fits in the range. Okay, so this is where kind of the implicit conversion can happen, because technically things still work, even though it's not exact type. Then we can have so I guess this is the best. Second best is the literal match, and the third one is generic match. F is a generic type, and A matches. For instance, it matches. For instance, A is integer, and F is a generic constraint parameter type, like T or T that could be either integer or character. Okay. So generics basically are weaker than those direct matches. So I guess if we would have two variants of a function, a procedure. One variant is we can probably just test it right here. So let's say that we define a procedure, add, okay, and we'll have A, which is integer, and B, which is integer, and we'll return integer. Okay, bam. But we also define procedure add, which takes type T, and it could be either int or float, and we define them like this, okay, and return that type. I know this still works, no problem, because we have the plus defined, the plus operator defined for both of them. So if we can probably just do here echo using int variant, while here we would just echo using generic variant. So let's do something like echo add 1 and 2. Okay, let's see what's gonna happen. If I'm gonna run it, I assume that this one is gonna match because it's non-generic. And we would even, let's start with that. The first one will be just integers. The second one will be floats, and this one doesn't define floats, so probably this one's gonna work. And the third one will be mixture. Now, let's do something like this, but let's make them I8 and I8, which will be, just int 8s instead of whole integers, which is probably what they mean in this literal match, because this is still within the range of normal integer. It's just, this one is narrower, so it's not exact match of a type, but it's literal match. So I expect it's gonna be int variant, then it's gonna be float, generic variant, and this should be again int variant. So let's see if this works. Wait, I probably just do Control-Shift-B in this one, right? What happened? I expected this, but I got that. Wait. I think it's supposed to be like this. There we go. Yep. Int variant, generic variant, but here it went with generic variant. Huh, interesting. I would have expected that it went with that, because the literal type is supposed to be stronger. Very interesting that it went with generic. I really wonder why. Why does it say something different? Unless we just define, here are multiple different categories how argument can match. Okay, I guess this is not the order. Okay. Taras is asking, do you know any good approaches of encoding data efficiently into URLs? I'm trying following codec chains like JSON to UTF-8, base64, and URL. Then we have JSON, UTF, bzip, base64. Oh, like I'm not sure what you mean by codec chains. You mean that first you take JSON, encode it into UTF-8. I mean, it kind of is already. And then you do base64 URL to fit the JSON in there, right? Or you do a bzip in the middle and do base64. I mean, the thing with base64 is that it expands the data, right? You end up getting a longer string than your JSON was initially. So first thing, minimize the JSON as much as you can. Second, I'm not sure how much compression would help. Maybe, I don't know how large those JSONs are, but I guess it could. But I believe there's a different encoding rather than base64. There's something more interesting that still fits within URLs. Maybe your favorite AI will help us, okay? I find base64 and encoding generate too long strings. Is there a more efficient encoding that is still safe for URLs? Base 85, exactly. Yeah, that's what I was thinking about. Because the larger the number, that means the more values you can fit in one character. And, no ASCII, you can imagine it's base 128 or what, base 255 actually, or something like that, 256. So this would be nice. Is it 30? How about Nope. Base 85. Look up base 85 and you might just get slightly better results. It even says about 20% shorter. It's just gonna be even less readable than base 64. Yeah. Alrighty, getting back to Nim again. Not this Nim. This Nim. So after generic match, we had the subrange or subtype match. A is a range T and T matches F exactly. Or A is a subtype of F. Okay, I see. So we basically have ranges and subtypes, and then we have integral conversion, which is A is convertible to F and A is some integer or floating point type. Okay, so this is specifically just for integers and floating types, nothing else. And then we have conversion match, which is A is convertible to F. Or possibly via a user-defined converter. Okay, I see. So that integral conversion match is basically a special case of conversion for integers and floating point numbers. I guess because one could do some extra optimization behind the scenes, maybe? Maybe. No, not base 62, base 85. Base 85. Base 60. Base 62 would be less compact than base 64. I don't know. Did I say that? It's slightly more compact than base 64. How so? Huh. Yep. No idea how it came up with that. Go figure. Oh, base 85 is not URL safe. You could make it URL safe as long as you handle it extra safe on your backend, depending on what backend you're using. Just make sure it's in last argument in the URL, and you're kind of good to go. I've seen crazy things. Oh, and one project at work years ago, everything was a GET request with a body. Everything was sent to the server via GET request with a body attached. Was it like, some people have not feel great when they're watching like movie with a lot of gore, or are afraid of jump scares or something. I usually enjoy both of those, but equivalent of that is basically a GET request with a body attached. It's about browsers. I mean, the browser really doesn't care what's inside of your URL. You can encode it however you want, as long as you just have the domain name proper. Whatever's after the slash, browser totally doesn't care. So you could make your own encoding instead of using question mark equals or question marks and then ampersands or whatever to delimit various things. You can just make your own, no problem. And if you have a use case that would really could use some better encoding, maybe it's worth, and you have control over those URLs, of course, then I would consider trying, hey, maybe 85, put it as the last argument, so that the earlier part of the URL you can have as a normal standard thing, but whatever's after, you do extra stuff. But then you need to probably have some kind of middleware or something that extract the data before something gets confused. Maybe. Don't know. All depends on what technologies you're using and how low level they can allow you to get. Okay. So there are two major methods of selecting the best matching candidate. Okay, so this is not the order of the importance. Okay. Namely, counting and disambiguation. Counting takes precedence to disambiguation. In counting, each parameter is given a category, and the number of parameters in each category is counted. The categories are listed above and are in order of precedence. Oh, so they are, okay. For example, if a candidate with one exact match is compared to a candidate with multiple generic matches and 0 exact matches, the candidate with an exact match will win. Okay. In the following count, PM counts the number of matches of the matching category, M, for the routine P. A routine P matches better than routine Q if the following algorithm results true. I really don't like those examples. Sure, it's cool to have it as an algorithm, but I'd like to have some examples. When counting is ambiguous, disambiguation begins. Parameters are iterated by position, and these parameter pairs are compared for their type relation. The general goal of this comparison is to determine which parameter is more specific. The types considered are not of the inputs from the call side, but of the competing candidates' parameters. Okay, so we have the text integer, right? One that takes normal integer, the other that takes the what do you call them? Generic one, and then we have a third one that takes something between, like N16. So if we'll do takes 4, then we'll definitely take this one because it's an integer. If we'll give it N32, so it will basically go for the generic if it's not exact match. Okay, because this was an exact match, this was an exact match, so I don't think it's gonna try to do any conversions. I guess if there were no conversions, then we'll try something. Not sure. And range 0 to 4 will also result in T because it's something generic. Okay. Tara says, thanks. I'm just trying to make shareable BF sheets without any backend. BF sheets will read data from URL. Oh, you can 100% do that because, yeah, in JavaScript, you would just get probably the whole URL without the domain in front. Forgot what that is. And Dart. Oh, I have no idea how it works in Dart, but yeah. I would just encode it with whatever you want. And you might even find an even better encoding. Possibly. If you want to live on the edge, you can probably just use Unicode. Because in theory, but yeah, then I don't know to what extent you can push it. Something tells me the modern browsers will be fine with, special characters. And I believe, at least in JavaScript, there are libraries that allow you to basically give it a set of characters and will make up an encoding for you. And yeah. There we go. No idea what percent of X is, but I'm sure you could just compress the hell out of it. The only thing is that your package might grow. depending on what you're gonna do. But yeah, there are ways. If this is your only parameter at the end, you don't do any extra stuff. So yeah. Oh yeah. For example, um, is there a Dart language package, or is there a library for Dart language that allows you to specify a set of characters for an encoding, and it will automatically generate the encode slash decode functions for it? There should be something like this. It's not aware. And it tries to write one for you. Yep. I'm sure there's something like that for JavaScript. If you can shove that into your Dart, it will be fine. If not, yeah, you can ask AI. Oh, it went with dark? Oh, because I said dark language. Dark custom. Is it Dart? Does it look like Dart? Or it came out with some dark language? Okay, it's so I guess there's a dark language. Sorry, man, Dart. Okay, now it's gonna implement it in Dart. Oh, that looks more like less functional language. Because the other one looked like was a bunch of pipes. Sure. If you want to get code, you can pause the thing and just grab it or something. Or I can just probably... Does pastebin still exist? Or something like that? Pastebin? There you go. Dart. Where is it? Name. AI junk. And how do I get it? The link here. There we go. There we go. There's some AI junk for you. You can just continue with your with basically correcting AI code again. It never ends. It's never gonna end. That's the sad part. Okay, so this makes sense. This makes 100% sense. If this algorithm returns ambiguous, further disambiguation is performed. If the argument A matches both the parameter type f of P and G or Q via substring subtyping relation, the inheritance depth is taken into account. Okay, so basically the lesser the inheritance depth, that's what I was gonna choose. Interesting how we get like a sneak peek into exactly how it works behind the scenes. Because most of the time we're gonna have all those things need to differ a bit and whatnot, and language will kind of try to find and match things for you. Here you just have it spelled out, like straight up with code on what the exact logic is. So we have A as root object, B inherits from A, and C inherits from B. So we have proc for A and B. So if we're gonna call C, something tells me it's it's gonna call the B because that's closer, than A. Okay. What is PP? Proc PP. Oh, we define it. Okay. A and B. Well, here we B and A. But when we call it, it'll be ambiguous because they, even though they're side by side calculated, they'll end up with the same score. Okay, sure. Yeah, that says pee pee poo poo. Yep. Alrighty. Likewise, for generic matches, the most specialized generic type that still matches is preferred. Okay, so if we have type T, and we have reference of T, and we have reference of a reference of a T, and we'll pass it the reference of integer, it will probably look for this one, right? Yeah. Yep. Okay, so overloading based on var T. Oh, this is fun. This is fun. This is something awesome. If the formal parameter f is of type var T, in addition to the ordinary type checking, the argument is checked to be an L value. Var T matches better than just T then. So let's say we have say hi that we can pass it an integer, the immutable integer, okay? And it's just returns that, okay? And then we're gonna have say hi with a mutable integer. So we have basically the same thing, the same argument. One is mutable, one is immutable. And what we can do here is that if we're going to define var to be .x, so we pass say hello x, okay? And we also make a mutable copy of it. So if we pass it immutable, it will just match the immutable one here. While if we pass it something mutable, it will call the mutable one. This way you can basically have two different variants of a function. One which is trying to perform something in case you have immutable data, and the other which is maybe a little bit more optimized, which is immutable data, and then you can basically have, you know, the things happen a little bit different way depending if it's mutable or immutable, which I believe it's super, super, super awesome. That says this is a name of a pig in Minecraft playthrough from PewDiePie. Is that the current playthrough? Because I saw some thumbnails and looked like he was playing Minecraft again, and again having a pet. This time not sheep. This time it's a pig. Oh, it's an old one. Okay. All right. I used to watch him a long time ago. A few things here and there from Japan. Alrighty. Lazy type resolution for untyped. Note, an unresolved expression is an expression for which no symbol lookups and no type checking have been performed. Okay. Since templates and macros are not declared as immediate, participate in overloading. Since templates and macros that are not declared as immediate participate in overloading resolution, it's essential to have a way to pass unresolved expressions to a template or macro. This is what the meta type untyped accomplishes. So this I believe is actually really important. If you want to start getting into templates and macros, this is something really important because you can actually use it to a great extent to implement, I would say, lazy evaluation to some extent, where you can define a template that if there's something specified, it won't even get executed. Won't even, because normally when you call a function, right? When I will do something normal, like if I will do, let's say that we have that procedure add, right? if I'll do echo add 1 plus 3 plus 5, and the other one will be this, okay? I have those two. What's gonna happen when I execute it? First, it will calculate this value. Second, it will calculate this value, okay? And then it's gonna call add with those two, okay? 1, 2, 3. This is the order of things that will happen. I mean, really, the real thing that's gonna happen is compiler will replace this with 11 during compilation, so it's not gonna really happen. But if you had, some other variable here, let's say var a is 1 and whatever, something, and, things happen in between, and you have this plus a, maybe times something, then first this is gonna get fully evaluated, then the other thing's gonna get fully evaluated, and only then it's gonna get executed while passing the evaluated stuff. But sometimes you might want to have, let's call it, debug add or something. And maybe the first parameter is some kind of true or false, right? A is larger than B. And if A is larger than B, you just don't want this thing to happen. But you want it there because for debugging purposes, if you have a flag for debugging, whatever, you want it to happen, still happen. You could actually have it so that none of this gets evaluated. It just gets passed into the template or macro as is, okay? Without evaluation. The macro will receive the whole thing. So inside the macro, you can have code that will basically make it that those values are like never evaluated if the flag happened or something. And I wonder if this is where we're gonna get this example like in practice. And Dara says, okay, I will go and have some rest. See you around. It was fun. Yep, it was fun. Have a good rest. And hey, have an awesome weekend. The least amount of AI for you during the weekend. Alrighty, so since templates and macros that are not declared as immediate participate in overloading resolution, it's essential to have a way to pass unresolved expressions to a template or macro. This is what the meta type untyped accomplishes. So we can find a template, rem, and we pass it as x, which is untyped, okay? So then we do rem unresolved expression undeclared identifier, right? We just call it that way. A parameter of type untyped always matches any argument as long as there is any argument passed to it. Okay, so just always work whatever you pass to it. Makes sense. But one has to watch out because other overloads might trigger the argument's resolution. So yeah, because we can have template rem and we can have proc rem. And this one here, if we're going to try to pass it, it will say undeclared identifier unresolved expressions. Untyped and var args untyped are only meta type that are lazy in this sense. The other meta types, typed and type description, are not lazy. Okay. So that's what I was trying to explain, the idea that something is lazy or not. So I believe we could do something like proc debug print, okay? Whatever. And the debug print will take x as untyped. Just something. We don't know what's in there. And we can define it. Let's just do this somewhere, let's say all the way at the beginning of the program. We're gonna say that we have constant is debug. And we're gonna say true. Okay? So here in this template, template, we can't use untyped in procedures. Template, when is debug? Echo X. Okay. And we're just gonna do straight up this. Or whatever. I'm sure there are better ways to do that. But what this means is that when we call debug print and we're gonna make 1 plus 2 plus b times a, okay? We're gonna even make it crazier with some parentheses and whatnot. If we're gonna call this, because it's a template, what it's gonna take, this is not gonna get evaluated. This is gonna be just said, you know what, this whole thing is X. And therefore it's gonna be turned into when is debug, echo, and then print this. It's gonna get turned into that code. That means that when we're running it, it's gonna execute this and say, oh, it's debug. So, and then it's gonna calculate it here. But if we have it set to false, then it's gonna say, you know what, not really, and just go somewhere else. Bam. And we might as well just make it if we want to have it, you know, a normal variable or something that can be changed during runtime or when initializing or something. So, you know, that's one way to just skip some code and totally skip evaluation. Because how often do you have a situation where you want to, you know, do a debug log, especially if you have something more interesting where you have to, you know, construct some kind of string. If I would have called the debug print and I would say the value of a is, I add a, and the value of b is this, okay? If I'll call this, if that was a normal procedure, that means that first I would need to call this whole, you know, if that was a proc, I can just copy paste it, okay? If that was a procedure and that needed to be whatever, a string, why not? And I would have this. What will happen? First, the string will be created, passed into here. And then I check I need to print it. It says no. Oh, okay. So let's throw that string that I just spent 100 times more time created than checking and then doing a check. While if we just had the template, it's just gonna take this thing and just say that this thing is this whole expression. Therefore, it's just gonna do boop, and you're not evaluating anything until you get the line where it was pasted in a template, at least. So that's the very important difference, and that's how you can optimize a lot of stuff. So remember, untyped doesn't execute the expression because it doesn't check it. It doesn't care what's inside as long as it's correct Nim code. And therefore, it just replaces the code behind the scenes. So you can be smart with that. Okay, so let's continue. This time we can go to var args matching. Okay. For that, we'll just see var args. So I guess we'll get to that at some point. Or we already went to that. I don't even remember. We might have went through var args. No, we went through open arrays. I don't know if we went through var args. We'll see. I just read about them so many times already that I don't remember. Okay, iterable. Now we're getting into more fancy stuff. A called iterator yielding type t can be passed to a template or a macro via a parameter typed as untyped. For unresolved expressions or the type class iterable or iterable t after type checking and overload resolution. Okay, I see. So we can define an iterator. Okay, that takes an integer and returns an integer. So basically it goes from I to the specified number and just returns to those numbers. That's it. So basically generate the number of numbers that we specified here. And then we have a template, toSequence2, which takes generic t, and a is basically iterable of type t, and returns a sequence of t. And what we have here, create a new return sequence, make sure that a is of type t, and then basically go over them, all those values, and return the thing at the end. So, okay. Is it part of overload resolution? Yeah, it is. Okay, I guess we can just pass iterable here. Interesting. So then we have a bunch of checks. So basically, for 3, the sequence should be 0, 1, 2. Okay. To sequence 2, 5 to 7. For AI and A. Oh, okay. AI in this case. So we iterate over those, return, and this. Oh, okay. I see. So because this just cares that it's an iterable of type t, which could be this or could be just a range. Okay, makes sense. Sure. Then it's gonna iterate over those. Assert that it doesn't compile if we're gonna try to call this with a sequence. Sequence integer is not an iterable. Okay, makes sense. But items of that works. Okay, because we just call it toSequence2.items, and there we have it. Okay, makes sense. Because we can basically extract an iterator from a sequence by calling items. All right, so great. We can just pass as templates and templates will be happy. But I wonder why the focus on templates. What if I'm just gonna make it a procedure? Can't I do that? Where did I go to the wrong screen? So let's replace the code with this, okay? And let's make sure that actually holds true, because it's weird. Yeah, we didn't get any errors. If I would put 3 in here, I just want to make sure that I'm actually gonna get error. Yeah, bam. So this works. What if I'm gonna make it a proc? I can't pass an iterable to a proc? I'm just surprised about it being a template. Oh, you can't. Expression items. Expected 1 off first mismatch at position. A is iterable of int. Huh. I guess we just can't specify that way. I am surprised. I thought that iterators could be passed around easily, but I guess you need to have a template for that. I am genuinely surprised. Too bad we don't have more explanation about that. But maybe at some point we're gonna get to actual iterators, and then we're gonna get more explanation. But that's the thing about the manual. It just is hyper focused on some specific subject and just goes deep into that without explaining a bunch of other stuff. So it's definitely not a read that you're just gonna read through it and understand everything the first time around. Okay. So we went over the overload resolution. Let's just go over overload disambiguation now, all right? And we'll be done with overloading. Overload disambiguation. For routine calls, overload resolution is performed, where there is a weaker form of overload resolution called overload disambiguation that is performed when an overloaded symbol is used in a context where there is additional type information available. So let P be an overloaded symbol. These contexts are in a function call, Q something something something, P something something something. When the corresponding formal parameter of Q is a proc type, Q. Okay, if Q itself is overloaded, then the Cartesian product of every interpretation of Q and P must be considered. Okay, we're getting into math and academic logic. I'm out. Ouch. In an object constructor, object something something field P something something. When field is a proc type, okay, analogous rules exist for arrayed set tuple constructors. And in the declaration like x of type T equals P when T is a proc type. So it's just a bunch of special things where that overload disambiguation happens, as in, some additional typey things. As usual, ambiguous matches produce compile time errors. I have no clue what it means. How about we do this? I'm gonna go to the Nim expert, which actually has the whole manual. Please explain the following part of the Nim manual in plain language. Throw in some examples, please. And we're just gonna give it this part. Let's see if it will actually let us understand it, because I am really not sure what this all meant. Come on. You can do it. Oh, we started with classics, certainly. Let me explain this part of Nim Manual in simpler terms. Overload disambiguation is a process that helps the compiler figure out which version of an overloaded function with multiple definitions, to use when there's additional type information available in the context where it's being used. This process is triggered in three main scenarios. When an overloaded function is passed as an argument to another function. Oh, I see. So basically, we have several variants of add, and we pass it as an argument to another function. Then, the language needs to figure out which one was passed, right? When an overloaded function is used as an object constructor, okay? And when an overloaded function is assigned to a variable of a specific procedural type. Okay, because, we define a variable that's some specific type, specific procedure type, and we assign this specific procedure to it, it can help infer which version we want to use. Okay, so let's say that we have print integer, print float. Okay, nothing fancy here. And then we have regular print. Okay. And then we have additional call printer. All right, so they all three have just one argument. That's x either t or float or integer. And we define that we want call printer, and we want to pass in a procedure that takes an integer. So if we're gonna call print int, the compiler will choose print int here for print float or print. Sorry, but we didn't pass anything. They would all need to have the same name. Yeah, that's AI going for it for you. This will be just print, and print with only this variable, and we just call it print. So let's actually try it. So it does 3, right? We just get rid of this part and this part. All 3 are called print. So if we're gonna go call printer, print, it doesn't know which one of those 3. So the compiler looks up what this call printer wants. It wants something that takes an integer. Oh, that means I should call this one, right? So let's try to run it. Bam, integer 10. But if I'm gonna suddenly change that, I will be printing in here something like, let's say I want the int 16, okay? Then when I run it, it will probably choose the generic one. Yeah, the generic, because it figured out, okay, there's nothing that matches exactly integer. Float won't work. So let's call the generic one because it's supposed to match everything. Okay, so yeah, that's a non-trivial approach to it. Then we have the other option of object construction scenario. We have type, the callback. Okay, and the callback is basically our procedure time. And we have my object on event callback. Okay. Oh, and object construction is basically when we create it here and we give this handle. Again, it should be a little bit more of a without those. And we call handle. I mean, we give it handle. It can figure out that, you know what, I need to use this one because the on event is defined to be a callback, which is proc of x. That takes x, not a float like this one. Makes sense. Okay, I'm starting to understand it. And then the last one is variable assignment scenario. So we basically define that we want the variable that stores this procedure, you know, with integers. So when we specify add, it's gonna choose this one, not this one. Okay. The Cartesian product part means that if both the function being called and the argument are overloaded, the compiler considers all possible combinations. Oh, haha, I see. So we have foo that takes, for example, this and that. So we have the foo that's being overloaded for both integer that takes the integer here and procedure that takes integer here, or the one that has both floats. And then we have something matching defined here, a procedure that either takes an integer or a float. If we call it this way, it will, it's like, okay, which foo should I call? And which bar should fit in it? Extra difficult problem. And here we'll say ambiguous call. Really? Even though I will put this here, which is an integer, it should infer that. And after it infers that, this should be easy. I wonder, will it be actually ambiguous call or will it figure it out? I want to do echo foo int. And here will be echo foo float. And let's just do the extra one, which is the f low. I mean, f, and we give it the x inside. Okay, there we go. We should be able to combine it that way, and this will be basically return we don't need to return anything. What am I doing? Echo bar int. This is just that. Okay. bar end, and here will be echo bar float. I want to see if this runs. There we go, full end. So it's not unambiguous, or it's not ambiguous, because it figured out, you know what, this is 10. I mean, this is clearly integer. Therefore, this must be an integer as well, if there's an option of that. If I will make this that, for sure it's gonna find integer. I mean the float. Yeah, there we go. Full float. And of course it doesn't. Let's do echo this and echo, or just fx. There we go. Because we want to call both, right? Yeah, they're both float. But if I would suddenly, you know, have the yet something else this is ambiguous, it would just try to still figure out until it can't at some point. Okay, so this is pretty powerful. Overloading, usually it's pretty powerful, or it absolutely sucks. And in most cases, it absolutely sucks. But here it's actually absolutely awesome. I wish, for example, C# had something as powerful as Nim. That would solve so many problems. Named argument overloading. Routines with the same type signature can be called individually if a parameter has different names between them. Oh, okay. So I can basically differentiate between them if I'll specify that, hey, this is that and this is that. Instead of just doing foo2, I can do foo x is 2, and we'll figure out, you know what, this one has the x defined, while this one doesn't. Makes sense. Not supplying the parameter name in such cases results in an ambiguity error. Exactly. Because, you know, they both take an integer. This is interesting. Yeah, we have two of them defined. Both of them take the, you know, exactly same argument. They just have a different label. This is nuts. So what that means is that if I would define it like this, I wouldn't be able to call, let's call them bar, okay? I wouldn't be able to basically do this, because it wouldn't know if it should use this one or this one. I hope it's not gonna know. Failed. Undeclared identifier foo. What am I doing? Come on. We have those foos. Okay, so let's, whatever I had here, your bars. Okay, bar. There we go. So basically I can't call this because it doesn't know which bar to use. Type mismatch foo bar. Literal. Bar is either this or that. You know, it already doesn't know which one. Expected one of those. So now, how do I specify it? Because I'm not calling it directly, so I don't have a way to specify it. Huh. So if you don't have to, don't do that. Have different names at that point, unless you know exactly how you're going to use it. Alrighty. Oh, now we're going through the interesting part, which is basically going through all the possible statements and expressions. And there's a lot of them. Okay. And this should give us a little bit of a background view on also how things work behind the scenes, I hope. And help us understand macros. So, statements and expressions. Nim uses the common statement / expression paradigm. Statements do not produce a value, in contrast to expressions. However, some expressions are statements. So expressions produce a value, while statements don't. So expressions can produce a value, but don't have to? Huh? Statements are separated into simple statements and complex statements. Simple statements are statements that cannot contain other statements, like assignments, calls, or the return statement. Complex statements can contain other statements. Okay, to avoid the dangling else problem, complex statements always have to be indented. The details can be found in the grammar. Yuck. But okay, so sure. Basically, complex statements are one of little things, while if you're gonna basically go to complex ones, that means where it's made of multiple things. Okay, but it's still a statement, as in it does not return a value. Statement list expression. Statements can also occur in an expression context that looks like parentheses, and we have statement, semicolon, statement, semicolon, and so on. This is called a statement list expression. Okay? Or you can just define it as those parentheses with a colon inside, or semicolon. And the type of this statement list expression is the type of EX. All other statements must be of type void. Oh, I see. So basically the last one is defining the type of the expression. Okay. So we have list of statements. Okay. And at the end we have expression, which means that it returns a type. It returns a value. Therefore, the type of this whole thing is what's defined here. Okay. One can use discard to produce a void type. Okay. An empty thing does not produce a new scope. Oh, this whole thing doesn't produce a new scope. This is very interesting. I never really used it, but let's take a peek at it. What could we do with it? So we can basically say let x is 2, right? Because it doesn't produce any value. At least doesn't, return on a value. Then we would have maybe var y is 3. Then we have something like y plus equals x, which would be total 5. And then we can have a statement that returns something, right? Which will be, I guess, just y. So I can say let z equal this. And because this is the type that gets returned, and this gets inferred from all of those, it'll be probably an integer. So we do echo z, it should be 5. There we go, it's 5. Oh, okay. So this is a fancy, simple way of, you know what, I'm doing this, I'm doing that, and whatnot, instead of going and writing it in a way that, because there's nothing stopping you from doing something like let a is, and you do block, and you start a block here, right? Let x is this, let's y is that, do that, and return y. And this should be the same result, echo a. Okay, well, for 5. In theory, this is more readable, but if you're really space constrained, this could be more fun. Or maybe if you're doing a for I in 1 to this. Possible, right? Echo I. Let's just do this. Will that work? Sure, works. We went from 1 to 5. Okay, I can see the value in this. But they also mentioned that this does not introduce a new scope. Does not introduce a new scope. Does it mean that if I'll run this, can I do echo X? Yeah. So that means that those variables actually got declared in this scope. It's not some little self-contained thing that just returns the value. It doesn't produce the scope. Very interesting. So it's literally as if we wrote this and this and this. And then because this returns, it happens to be here. Okay? This is equivalent of this. Huh. Well, that's good to know. That's definitely good to know. And that also means that in this for n loop, where inside the range we were computing this, that means that all those expressions were kind of added before we started the loop. Very interesting, very strange, huh? Therefore, now I'm curious. So what if I'm gonna do the for in loop, right? For I and 0 to this thing. Echo I. Because now, what is the scope of this? Where does it exist? Does it mean that after the loop, I can just do echo Y? Does it still exist? Yeah, it still exists. So even though it wasn't set the scope, like, from within the loop, whatever is defined from within the loop is defined in basically the parent scope. Okay, interesting. I like it. While otherwise, because we have this, let's just get rid of that. Will that still work? No. Okay. So look at that. So this didn't introduce any scope, but the scope of it was, I guess, this whatever in is, this definition. So we basically made several instructions inside this little hidden scope that's separate from this main scope. Okay, I see. So basically, when using this kind of statement list expression, you need to be careful where you're creating it to not pollute your scope with some additional, things existing there. Very interesting. Because remember that this is not equivalent of let z equals block, and we have this. This and that is not equivalent because block creates a new scope. Therefore, whatever you define here, after this block ends here, it doesn't exist anymore. It's not defined. It's not accessible. Okay? This might be a really handy tool. Okay. Discard statement. Example. Procedure P that takes X and Y as integers and returns an integer. We just do, return X plus Y. And what we can do here is call it, but we can discard whatever it got returned. So discard the return value of P. Because Nim will complain that, hey, you didn't discard it, okay? I'm just gonna run it. it's gonna be fine and run. But if I'm gonna remove that, it knows that this will return an integer and it's like, hey, I need to do something with it, okay? Expression is of type int and has to be used or discarded. In this case, we can just discard it. So tell explicitly, I'm not doing anything with that value. I didn't forget about anything. The discard statement evaluates its expression for side effects and throws the expression's resulting value away, and should only be used when ignoring this value is known not to cause problems. Okay? Because in theory, you could ignore something that you were supposed to save, and because suddenly it's lost, some other stuff, stop breaking, whatever. I mean, worst case scenario, unless you do something weird. But yeah, discard just allows you to discard it. Ignoring the return value of the procedure without using a discard statement is a static error. Exactly. Nim will complain. You said you're going to return a value. You didn't do anything with it. You probably made a mistake. That's the reasoning behind it. The return value can be ignored implicitly if the called proc/iterator can be declared with the discardable pragma. Okay, so that's the thing that we can basically override that rule. If we define our procedure and add the discardable pragma, that means, we don't need to worry about that return value. We can basically tell compiler, you know what? This value that we're returning is kind of optional. It doesn't matter if it gets discarded, which is great because sometimes you just want to make some procedure that does something that's important to you, and at the end of it, you ended up with some kind of value that, you know what, sometimes I'm gonna need it. But let's say most of the time when I'm calling this function, this procedure, I won't be using that value. So you just mark it as discardable. Therefore, you can just keep calling it, like, delete this, delete that. But that one time, you can just do, delete it, and let's save the ID of it because I need to check somewhere else if something else needs to be deleted or whatever. However, the discardable pragma does not work on templates, as templates substitute the AST in place. So, for example, push discardable. A template example that returns a string and just returns a string, right? And then we have pop. What the heck? I would call example. This template will resolve into this, which is a string literal. And since discardable doesn't apply to literals, the compiler will error. Oh yeah, absolutely. Because after we call it, this just gets replaced by this, and we don't have any call really anymore. It's not something that just returns something. We just have random value here dangling. An empty discard statement is often used as a null statement. Exactly. So we can do, if and for else, or it's most useful in something like case of this, of that, and for everything else, just discard. We want to explicitly ignore it. The other scenario where you would use it is, for example, define proc test equals, and you just do discard. So that you have the definition, you can already write test. It's just when you run it, nothing happens. Just a placeholder because maybe you were testing something, playing with something, or I don't know, maybe this is a method that needs to be overridden or something. Who knows? Probably a million reasons knowing Nim. Void context. Okay. In a list of statements, every expression except the last one needs to have a type void. In addition to this rule, an assignment to the built-in result symbol also triggers a mandatory void context for the subsequent expression. Okay. every expression except the last one needs to have the type void. So this will be invalid, where we define that we return the type string and we assigned the result to be some value, right? We already did that. Therefore, we cannot return the string in this way, right? Because we already specified that, yeah, we are actually using that result. But if we're gonna just, not use that result, we can just return it this way, because the last statement, it just works, okay? But remember, this needs to be a last statement. var statement. var statements declare new local and global variables and initialize them. Okay. New local and global variables, okay? A comma-separated list of variables can be used to specify variables of the same type. So we can make the whole section var, where we specify a is integer and default value is 0, or x, y, and z are all an integer. If an initializer is given, the type can be omitted. And the variable is then of the same type as the initializing expression. Okay, so here we could just skip the int, because 0 just looks like an int, so it will assume that a is int. Variables are always initialized with a default value if there is no initializing expression. The default value depends on the type, and it's always a 0 in binary. So here it says the variables, as in var, but the same stands for something like let, and I believe a constant will also assume a default value. And this way, will just be a default value. So we can take a peek at what the default values are, because this is sometimes, a little bit hazy for me. The default value depends on the type, and it is always a 0 in binary. Always a 0 in binary. Very good to know. So for any integer type, the value will be 0. Same for float. For character, it will be the character 0. For boolean, it will be false. Reference to pointer type. Reference or pointer type. Nil. So we know that nil is basically represented by a bunch of zeros. For procedures, for procedural type, it will be also nil. So this already tells us that procedural types, when we say that something can be a proc, can be assigned a nil. And I believe that's because procedural type is just literally a pointer to where the procedure lives, right? So if we're gonna have a nil pointer, it's just empty, zeros. Then we have sequence, so I guess empty sequence is again a bunch of zeros. Pointer to nowhere. A string, empty string is again zeros, because behind the scenes, I believe strings are defined just as an array of characters. We have predefined some length for them, but really we're just storing a bunch of zeros, I think, unless this is straight up, again, a reference. Therefore, a hidden pointer. Not sure. A tuple. A tuple that has x, y, and whatnot is basically 0 default A, 0 default B, and 0 default for anything else. And the same stands for objects. So basically, if we define an object, all the values will be, Nim will try to, by default, assign all the 0 values to all the elements. For array from 0 to something, it will be basically 0 default for every element. Okay? I think. Doesn't mean the array is predefined, but I don't think so, because I was trying to do that and I don't think all the elements were already constructed for it. Not sure now. I am really not sure. Let's try that. So what if I'm gonna create an, like let, var, because we're doing var, a of type array from 0 to 10, which is an integer, right? Let's do that. And can I do for everything in a echo the value? Okay. Can I do that? Wait, I made a range. Sorry, echo a and index of I. Okay. Okay, so they're all zeros. But what if instead of that, I would specify that this is an object? Let's just define type. What the type could be. Something like, I don't know, x, which is integer, and y, which is int 16. Okay? We just got those two values here. And therefore, wait, what the hell? Point to d. Well, let's call it point to d, which is an object, and it will have this weird type. And we'll set it's an array of point to d. Doesn't mean that all those points, they'll be zeroed. Yeah, they're all zeroed. Okay, so if we define an array of, 10,000 objects, it should just create 10,000 objects. It's just your memory won't be happy about it because it's all in the stack. And therefore, yeah, takes up some very precious memory. Also, range t is default t, and this may be out of the valid range. That's strange. So basically, t type like, yeah. Oh, I see. Huh. So if we would specify that var c is of type range from 3 to 100, and we just finish it, what's going to happen? We're going to echo c. It still prints those. C shows 0, okay, in that range for some reason. Well, 0 isn't a part of it, but byte set as a bunch of zeros will represent 0, therefore it may be an invalid value. Okay, so be careful of that. Yeah, out of the valid range. And t equals enum, cast t to, cast 0 to the t, and this may be also an invalid value. Oh, so this is very important, I think. So let's say that we have type, whatever, what starts with 1 or like 5? Scores, okay? You're playing darts or something, or designing a game or something, and that'll be an enum, and you have basically that, you have bullseye, and I don't know, is that 50 points or something? And maybe perfect or good, average, and bad, okay? I mean, this is stupid. Bullseye, maybe small, which will be 25, and large target, which, let's call it target points. So we have those 3 possible values, okay? And we assign them numerical values so that we can start calculating things while we're storing them as something else. So if we're gonna define var target points, what the hell? TP is of type target points, and we don't define a value, and if we're gonna do echo TP, this will store value 0, which is an invalid for that integer. That's very interesting that it's actually allows those invalid values. It failed. Invalid type description target points for var. Ordinal or something like that. I don't remember how that worked. TP to integer. Can I convert it that way? It should work. Target points for var. Oh, I'm duh. I have equals instead of this. That's why. Yeah, this will be 0. If I'll just run without it, it will be also 0. Ah, now it's straight up. Illegal storage access. Attempt to read from nil. Wow. So yeah, this is again invalid. So be careful. I'd recommend to range and an enum always assign default value, because you might not like your results, and at least be aware that this is an error that can happen. Okay. The implicit initialization can be avoided for optimization reasons with the non-init pragma. So we can define var, which is A, which is don't try to init it. So if we, okay. So if we want to make a large array, which is again on a stack, that basically, that continuous memory on a stack, we can just say, you know what, don't bother initializing it, because suddenly we're not only, I guess, reserving memory for it, we're also going and zeroing everything just so that we have a nice clear memory that everything is zeros, right? If a proc is annotated with the non-init pragma, this refers to the implicit result variable. Okay. So this will make sense, and then we can just start assigning values to it ourselves, because maybe you want to just go through a loop and assign everything a specific value, and you don't want this to basically do weird stuff. So what's gonna happen if I'm gonna initialize it and try to read it? So we have a bunch of characters, right? If I'm gonna do it this way, I can do for I and for everything, just what? Echo those characters, okay? Because these are our characters, so I should be able to print them out, I believe. And they should be all like nothing. Yep, bunch of nothing, and then finished. What if I'm going to make it non-init? Will it throw me an error or something? Or will it allow me to just read random memory? It looks like a bunch of zeros, but I am not 100% sure if that's actually correct. Huh. If I'll make it integer or something, probably nothing either, right? Yeah, bunch of zeros. Interesting. Not sure what exact benefit it is, but just in case, you can mark something as to initialize it. I'll do it myself. And for procs, it basically means don't bother creating the result value, because you probably take care of it yourself, or maybe you just define, it's possible they're gonna return something that they're just gonna copy from a constant, as this is a common result or something. I could imagine it, let's say you make a vector library and you just store common vectors like up vector, zero vector, or some other specific types, and you don't want the procedure that is supposed to return it, in some cases, bother with initializing the 001 so that it sits there in the background and you assign values to it one by one or something, while in half the cases you're not even using that value because you're going to return something that already exists somewhere else. The implicit initialization can also be prevented by the requires init type pragma. The compiler requires an explicit initialization for the object and all of its fields. However, it does a control flow analysis to prove the variables has been initialized and does not rely on syntactic properties. Okay, so we can define the type, that's an object, and requires init. And then we can define a procedure where we create that new object. We don't give it a value initially, and then if it's this, we create it. If it's something else, we create it. And therefore, in all the possible scenarios, by here, we will already have that thing here. And requires init pragma can also be applied to distinct types, given the following distinct type definitions. Okay. Distinct foo requires init, borrow this and that. And string the okay requires init as well. And this way we basically have to do that. The following code block will fail to compile. But these will compile successfully where we actually explicitly create them through this. Okay, I see. But I want to take a peek at this. So with something like that, we could basically say that, okay, we have object, yeah. Too bad that you actually have to define it on a type rather than have an option of defining something like, behavior like that somewhere else, like, it's an integer. And I know that I'm assigning it value here and there, but I just want to define it here and not bother with some kind of default value. I mean, it kind of makes sense for objects, but I would like it to be a default in some cases where it infers that, all the possible possible pathways would automatically, it just detects that I took care of it. You don't need to initialize. Yeah, don't know. Although maybe it's an experimental feature. Who knows? Okay, so let's move on to the let statement. A let statement declares new local and global single assignment variables and binds a value to them. The syntax is the same as that of the var statement, except that the word var is replaced by the keyword let. The variables are not L values and can thus not be passed to var parameters, nor can their addresses be taken. They cannot be assigned new values. That's the important part. It's you just define it once and that's it. But unlike the constant, you can do it during runtime. Well, constants are purely compilation time. For let variables, the same pragmas are available as for ordinary variables. Great. As let statements are immutable after creation, they need to define a value when they are declared. The only exception is if the import C pragma or any of the other import X pragmas is applied. In this case, the value is expected to come from native code, typically a C or C++ constant. Excuse me. Okay. Simple enough. Special identifier underscore. The identifier underscore has a special meaning in declarations. Any definition with the name underscore will not be added to scope, meaning the definition is evaluated but cannot be used. As a result, the name underscore can be indefinitely redefined. Okay, so we can just do something and we kind of discard its value. How is that useful now? I mean, it could be useful when you're defining like, anonymous functions or something. But in this case scenario, I don't know. You could just run discard or something. Unless for some reason you need to call the assignment operator for something to work. I don't know. It's weird. But hey, sure. I mean, that could trigger a copy, could trigger a bunch of other stuff because assignment operator means that your code executes slightly differently, handles values differently, I believe. So maybe it has some strange esoteric use, but I guess in normal day-to-day code, you won't be really writing that. Tuple unpacking. In a var, let, or constant statement, tuple unpacking can be performed. The special identifier underscore can be used to ignore some parts of the tuple. Okay, so here we're using it. A procedure returns tuple. And it returns a tuple of 3 integers. For example, something like that. So you can basically let x something z. So basically 4 will be assigned to x, 2 will be assigned to nowhere, so we'll be basically ignore it, and 3 will be assigned to z. So, you could, in other words, say also do, let, in this case would be basically the tuple is returns tuple, right? And then let x is this and that. I mean z. So this is an equivalent of that. Much simpler, way easier to read because I know, I'm getting that, and ignoring that. Perfect. This is treated as syntax trigger for roughly the following. Oh, there we go. Temp tuple and x and z. I promise I didn't read ahead. For var or let statements, if the value expression is a tuple literal, each expression is directly expanded into an assignment without the use of a temporary variable. Okay? Okay, so this basically skips this part because the compiler can figure out, you know what, I might as well just do that. It's kind of more optimized. So let's skip all the weird unnecessary stuff at that point. Tuple unpacking can also be nested. Ooh, that's fun. So procedure returns nested tuples. So it returns a tuple that has first value is integer, then second value is a tuple of 2 integers, and then we have another tuple, another integer. So that's fun. And therefore we can just go for it. Hey, that's awesome. Can I ignore like everything after that? Maybe? That could be interesting. Constant section. A constant section declares constants whose values are constant expressions. So we can basically define like, hey, we have a bunch of constants and indented we have pi and we have a constant evaluation that basically does this contain that, okay? Which is computed at compile time. And remember, Nim can do a lot of compile time, which is absolutely awesome. Once declared, a constant symbol can be used as a constant expression. So yeah, see constants and constant expressions for details. And at some point, we will probably get to it. Wow, there is so much. Unless we already went through that. Don't remember. Static statement / expression. A static statement expression explicitly requires compile time execution. Even some code that has side effects is permitted in a static block. Okay. So, yeah, it requires compile time execution. Even some code that has side effects is permitted in a static block. What do you mean? Oh, as in I can echo here. Okay, and this will happen only during compilation, right? So if I'm gonna plop this, right, because we have procedure get number, and it just returns the number we gave it, echo it inside the static, and then echo static this. So below call evaluates. So let me just, static can also be used like a routine. Okay. A compile time, but its result get used at runtime. Oh, the result will get used at runtime. Huh. So it's basically like hard coding 1 to 3 at this point. Let's look at that. That's awesome. So we just run this, run that, and then we do echo get num 321. Okay. If I'm gonna save it, I'm gonna run it. Okay. We got 1 to 3, which is this one, another 1 to 3, which is this one. This one was during runtime, but it remembers the compiled stuff from compilation time. And this is just during runtime. So if I'm gonna go into the terminal, okay, ls, we can see that we have that enter.exe that we just compiled. I'm gonna run it. That means I'm not recompiling anymore. I'm just running. We only get 2. This one, which was already here, pre-compiled. Compiler basically, what compiler did is, you know what, statically run this code, it ran it with 1 to 3, returned 1 to 3. So it just defined it as this. So the code that we actually run during runtime is this. Awesome. Nice cleanup. And you could probably do a bunch of additional stuff here. I wonder, what if we have something like variable a is, I don't know, 555, okay? Can I make it that a is this during the static thing? Is that possible that I use this variable here? Or do I need to do like constant variable? I don't know if that's possible. And then we're gonna do echo a. And then, wait, echo static a. And then echo a. I want to see the difference between those. Can I run it? That's the first question. No, cannot evaluate at compile time A. Is there const var? Gosh, I recall there being something like variable const or something. When was I using it? Let me just check here. Let's got a new conversation here. Is there some kind of const var so that I can assign values during compilation time, but then during run time they get reset? Is that a thing? I recall using something like that where I could redo values, change the values. Hmm. can't remember now. Unless I make it a ref int. Is that possible? What the hell is gonna happen now? Expect a ref and new. What the hell am I doing? Oh, this is funny. I'm trying to do weird stuff. Gosh, I swear, I thought I was doing something of this similar stuff. Because that would mean that this would compile to whatever A was during compile time, but then during runtime, A would be different. So here would have the old hard-coded value, while here would be the new, not hard-coded value. But I can't remember what I was doing there. And this doesn't have a clue either. Oh well, too bad. There are limitations of what Nim code can be executed at compile time. See restrictions on compile time execution for details. It's a static error if the compiler cannot execute the block at compile time. Let me just take a sneak peek at what we went through previously. Type equality, that was today. Auto type, avoiding those distinct type, procedure types, nil. References, I don't think it was anywhere here. Set type, casting, objects, enumeration. So this is all just types. Restrictions on, yeah, constants and constant expressions. Maybe here we'll get a hint. Oh, we just need to do the compile time. That's what it is. There we go. So we can do var a compile time, which is type integer, right? There we go. And we can give it the default value of 555. Okay, that'll be its default value. Then during compilation time, we assign it a value of this. And then we do the first echo. We specify that it needs to be compiled during compilation time, the A. So we basically replace it with what this was during compilation time, and then second echo will be the one from runtime. So let's see what's gonna happen. There we go. 123, 555. If I'm gonna go to the terminal and run the exe, we get the same thing. First echo shows the thing that was run during compilation time, and the other one shows what was happening, during runtime. So that's another interesting thing. We can have this value be different in different spaces, and we can freeze those values, which is awesome as well. Okay, now I feel better that I actually went back and understood it. Compile time for the win. Okay, type relations, we went through all this, constant section, and static, statement, and expression. Again, this whole static thing is very interesting. Another interesting thing that you could do here is basically add a little code, little checks somewhere where, maybe when you're compiling, you just do a check on your config if everything actually makes sense just during compilation time, but don't touch it anywhere else. Little things. Okay. Now it's like we're getting back to basics. If statement. For example, var name is readline standard in. So we basically read the name from the input. And if name is Andreas, what a nice name. If it's nothing, don't you have a name? And otherwise, like, oh, boring name. Okay, so just if, elif, and else. The if statement is a simple way to make a branch in the control flow. The expression after the keyword if is evaluated. If it is true, the corresponding statement after the colon are executed. Otherwise, the expression after the elif is evaluated if there is an elif branch. If it is true, the corresponding statements after the colon are executed. This goes on until the last elif. If all the conditions fail, the else part is executed. If there is no else part, execution continues with the next statement. In if statements, new scopes begin immediately after the if, elif, and else keywords, and ends after the corresponding then block. For visualization purposes, the scopes have been enclosed in those, okay? In the following example. So if, and this is where it begins. So, okay, so basically where we test value, it already is inside scope. Oh, that's handy. So we have like if, and we can make let something is something, right? And then we just return if it's a match. Therefore, everything that we defined here, like the variables, they're available right here. Okay, that makes so much sense. Therefore, you could do basically things like if, let input is read line start in, right? And the input is exit. We do quit, or we do like echo bye. Okay. But we can just do bye because, and we give it the input. Okay, because we have access to it because we defined it right here. And this is maybe not like the best example of it. Something more useful would be when you often have you often try to do something, right? So let's say if let cached value is get cached value. Okay. And then we're basically checking if the cache value is not empty or whatever, right? Then we're gonna do cache value is this and that and do your stuff. And we can use it if we received it. Although we could probably do something like cached value is this, or maybe even destructure it, right? Is whatever has value, and cache value is here, okay? And we do that. We destructure the tuple. And then for actual check, we do has value, okay? So only if it has value, we're just gonna return it. Otherwise, we know it doesn't have the value, we just do something else, okay? So this is handy because suddenly you don't have to specify it here, okay? Because, nothing stops you from doing it here. Let it be here, okay? And here you just have this. But what it means is that by the time you have this else, this still exists. By the time you're already out of a statement, you do something else, this still exists. So you might have a bunch of stuff already like over-defined here. And it's often the case where you have basically a bunch of those one after the other. So it's much nicer if you can just do this, right? And not worry about them interacting with each other. Something like that. And CPN says, hi, hello to you too. I was wondering if we're going to join today. How are you doing? How is your weekend morning? So I believe that the idea that the scopes start immediately after if, else if, and else. I mean, else doesn't matter much, but an elif and if, it's absolutely awesome. Go has something similar to this. Yes, it does. Here is just described that, that little nice thing about the manual is that sometimes it goes a little bit too deep. And here they're basically showing that when you type an if, the scope of variables and whatever already begins even before you start typing the what do you call them? Before you start typing the come on. Before you start typing the condition. You can run whatever expressions you want. You're making Tetris that runs on terminal. That's awesome. Yeah, Tetris is not that trivial, I think, initially. Yeah, there will be a few interesting edge cases there that you don't think initially about. Yeah, that's cool. You're writing in Go or some other language. Case statement. Okay, and a case statement, again, we read the line, but we can basically use case like a switch, and we can have few variants, like if the line was delete everything, or restart computer, run this. If it was go for a walk, run this. If the then we have elif. Interesting. So instead of off, we can have elif. Really? So this is like if, and we can suddenly switch to else if. Elif line length is 0, but look how we're already using this line here. And this, and otherwise, just run this. So like, I like how we can kind of transition from having those statements here that we can exhaust a few of those initial things, and then we just switch here. No, you cannot use curly brackets. This is just here that for visualization purposes, the scopes have been enclosed in this and that. So nope, no curly brackets. Span says, I'm using C because memory management isn't an issue for this project. Okay, I see. You just define the big table and just go for it, right? And you have only one thing falling at a time. So, yep, sounds like something simple. And then for shapes, when you want to move them, you probably just switch on and off several, like bits on and off. Like switch off the old ones and switch on the new ones, because you probably don't even worry about other stuff. Yep, cool. Yeah, for C, that's a fun project. I'll need to try C at some point or like pick it up. I don't think I ever wrote anything in purely C. Even when I was writing code for Arduinos and some of those development boards, it was more like C++, I think, when dealing with Arduino IDE. So yeah. But I believe you can use Nim also on Arduinos and stuff, but then you would actually need to manage your own memory, because I don't know if they have garbage collection. The thing about Nim is that you can actually choose if you want to have garbage collection of that style, of another type, or if you want to deal with memory borrowing, or if you want to do everything manually, whatever. All blocks are defined in a big array, constant, uint8 blocks. Okay, 7 by 4, and the 2 is, I guess, you have 2 states in there. Not sure what a 2 goes for in that array. Unless you're doing double buffering. All right, so we've got this as an example of the case statement. The case statement is similar to the if statement, but it represents a multi-branch selection. The expression after the keyword case is evaluated, and if its value is in a slice list, the corresponding statements after the off keyword are executed. If the value is not in any given slice list, trailing elif and else parts are executed using the same semantics as for if statement, and elif is handled just like else if. If there are no else or elif parts and not all possible values that expression can hold occur in a slice list, a static error occurs. This holds only for expressions of ordinal types. All possible values of expression are determined by the expression's type. To suppress the static error, an else discard should be used. Yep. So in other words, if we had defined, let's say, if we said, we do case, let's do let x is integer and is 20, right? And we're gonna do case x, and we do off 0, then echo 0, 1. Right? If we're gonna try to run this code, it's gonna say, you know what? You didn't cover numbers from 2 to whatever 32 trillion or something, right? There we go. Not all cases are covered. So we would need to add a lot of the stuff, but I think we can do off 2 to 500, right? Of 5001 to here, medium, and let's do off this to, I guess we can do high of integer. And will that cover everything? Oh, we don't have negative, so let's make it a uint. Just to simplify our lives a little bit. I wonder if that's gonna work. Yeah, now it worked. It figured out that I actually covered all the possible cases. Great. But with this, we might as well just do this minus 20. Can I do that? Can I actually do some math here? If yes, I will be very happy. Because I'm gonna try to run this and should tell me that I didn't cover everything. See, not all cases are covered. So I can do else echo too large. Now it knows everything's covered because I added the edge case scenario instead of dealing with recalculating that. I can just say for everything else, just do that. But if I could just cut that one out, it will know that the one isn't covered. Oh, wait. It actually, because we have else. That's why. There you go. Only ordinal types, floats, strings, and C strings are allowed as values in case statements. Okay, but for strings, it just can't do the check if all possible values were evaluated, because string has practically infinite possibilities. So it will always require you to have that else to cover that last case. But so yeah, only ordinal types, which is all integers, enums and stuff, floats, strings, and C strings. Cool. CPN says all the new languages like Zig are just taking the features of the older languages. What do you mean by just taking? As in not improving upon them? I mean, in my opinion, they're just concepts that really work, and it's good to have them. Because can you imagine living without a switch statement and doing a bunch of if else's? Tofu the Lofu says, "Hi, are you coding?" I'm not coding currently. I am just reading through the manual. And I presume you asked it a long time ago, and I don't know if you're still watching. If you're still watching, please let me know. Okay, so for non-ordinal types, it's not possible to list every possible value and so these always require an else part. That's for strings and C strings. And I guess floats are considered that. I mean, floats you could cover. No, we can't cover all the possibilities because, if you would have ranges of floats, and hey, I don't think you can define ranges of floats. The thing is that you can't say that range from here to here, and then from a number larger than the last one to the next, because you can always fit something between. Unless you would go totally nuts and do what Nim allows you to do, which is write your floats as in a binary format, which is nuts. Okay. An exception of this rule is for the string type, which currently doesn't require a trailing else or elif branch. Interesting. It's unspecified whether this will keep working in the future versions. I did not expect that. Okay. NCPN says, I mean, there's nothing wrong with it. You can use ... to cover more cases and switch statements in Zig too. I thought it was unique to Zig. Oh, that's definitely not unique to Zig. For example, in Nim, this kind of stuff is often considered pattern matching, where you have, in C you will have probably something like switch, right? Switch on X, and case 0 do this, case 2 do this, right? And case that do that. And I don't know in C you can do ranges. I don't think so. That's when you would start reaching to, if else statements. But in Nim, sure, you can make those ranges. And then some languages allow you to do way more. I don't even know how much you can do, but let's take an example of something like C++, C#, for example. I didn't use it a lot. I haven't used it a lot. I just didn't have a lot of specific scenarios. Let's search for examples of pattern matching in C#. Okay. There's an overview. Okay, what we can do with this in C#. So we can do null checks. The thing is pattern matching is that you can often use it outside of just switch statements. Will they have type tests? Everything is if else. Yeah, here you have normal switch statement, okay? And you just switch normal by normal string labels, right? Nothing necessary. And this is the default case. And then you can have, relation patterns. Everything larger than 32 and less than 212, do this. If it's less than 32, do that. And hey, that's fun, right? Especially that you have option of probably larger than or equal and whatnot. And this could probably work with floats. I presume. I am not actually 100% sure. Multiple inputs, I don't know. Sure, you can do that. You have an order. An order is basically an object that has items and decimal, right? You can basically say, you know what, for everything, for orders that have items, more than 10 items, and cost is more than 1,000, do this. And you can just do a bunch of weird stuff. Sure. If null was passed, do this. Even crazier. This is something I find really fun sometimes. Let's say you have a list of values, right? Let's consider these will be probably objects, right? But you have a list of them. You can basically say, we have those balances, like take the balance and add and switch on the transaction. And you can say, ignore the first value. Oh, because this is a list of values, right? Yeah, this is a list of strings. Match all those, only the lists that, ignore the first value. The second value in the list is deposit. Third one is ignored. And the fourth one, I guess you just extract as a variable amount. And therefore, you can return as this. So you can just declare things that way. Writing code with if-else statements for, this is relatively simple, but look at that. When you have fee, you have only 3 values. Here you have 3 values. Here you have however many there are inside, and the last one is this. Yeah, there is a lot in C#. There's really a lot in C#, and that's probably why I like it. But now imagine coding that, especially that this is, still a relatively simple scenario. You maybe don't worry too much about performance because you're just gonna write some software that runs just somewhere on server. You just want to make sure that what you're doing with money is correct, but not too performant, because for you it's probably cheaper to just get another server running rather than worry about doing things performant way and paying, for extra month of development. This will ensure that you have this defined, and defining it with else statements will be just a nightmare. Nightmare to maintain, nightmare to change, because suddenly if some rule changes, you'll need to rearrange all those if statements. It's just a pain. And with the rate at which things are changing, it's just horrible. Yeah, but that was one of the last ones, and I know there are languages that can allow you to do even more. And I wish Nim could do a little bit more, in my opinion. When it comes to case statements, especially that in Nim, case statements are limited to numbers, floats, strings, and C strings, and you can do by other types and stuff. Yeah. So yeah, sometimes you might be hating on a language, oh, this is not performant, blah, 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 but there are use cases where it just works. And yep. Okay, where do we finish at? Because case statements are checked for exhaustiveness during semantic analysis, the value in every off branch must be a constant expression. This restriction also allows the compiler to generate more performant code. So that's another restriction. The thing actually needs to be known during compilation time, at least what kind of value, what kind of type is there going to be. You can't just make it whatever it could be, which poses some extra restrictions. As a special semantic extension, an expression in an off branch of case statement may evaluate to a set of array constructors. The set of array is then expanded into a list of elements. So if we have classify, okay, and we have case of first element of S, sim characters, comma, underscore, either this or that, do that. List from here to here, do that. And blah, blah. So suddenly, this sim characters is just a list. It's purely a list. So if we're going to plop it here, it's just gonna be, I mean, this is a list of ranges in this case. It's just gonna pack them out here so that, yeah. The only thing is, this needs to be constant. You can't just plop it something that was evaluated during runtime, which is 100% understandable. It would be just nice to have an equivalent of it that can run during runtime, but I'm sure one can do that or somebody already wrote that. The case statement doesn't produce an L value, so the following example won't work. So if we have type foo, which is a reference object that contains x, we create a function that provides the foo and returns a variable sequence of strings. It doesn't work. Case true, huh? Of true. Wait, what? This is confusing. Why would I do that? Oh, as in L value means that the thing that returns something. Case doesn't just return. Okay. I see. This can be fixed by explicitly using result or return. And then you just say result is this, result is that. Okay. Makes sense. So I guess one couldn't do something like let x is case of true is 1, else 2. And echo x. Can I do that? Oh, I can. I guess when it comes to procedures, it just doesn't work. Or does it? What if? I'm gonna actually try it. Let's make a proc. Walala, right? And we just do this. And walala will be of type integer. That's it's gonna return echo walala. I want to see if that works. It works. Manual is outdated. Say false. And we get 2. Okay. Manual, you're not good to me. Where were we? I want to scroll all the way up to just make sure that we're watching, yeah, for 2.8, the newest version. Go figure. Somebody wants, they can basically submit an issue with documentation that in that spot, the manual is wrong. Where is that? Where were we? And a procedure, we were in the case statement. I'm just gonna write it down. I'm gonna submit it off the stream because this is too bad. Case statement can return L value. Unless that L value is something else. Because let's just take a look at it again. We gave it foo. And we want to return a sequence. Huh? How would that be a sequence? Oh, because this is a sequence. I want to copy that example because this is weird. What the heck is going on? Yeah, exactly. I'll try to run this whole thing because there's something extra going on here. Because foo is a reference type, okay? So we want to return the x from the reference type, and that's it. So we do var foo is this, okay? And we want to get x, and to that add that. I mean, this should work. Oh, expression has no address. Oh, what? 7. Oh. Ah, I see. So basically we can return a reference thing. Now I think I understand. Okay. Very interesting edge case, something that I wouldn't expect, to be honest. So we can return reference objects like that randomly. Very interesting. I would not expect that. So I guess I can scratch that out. There's no error. There are just those weird L values which represent reference objects. References. Okay, let's take a peek at the when statement, which might be confusing to some people because how is it different than if statement? So when size of integer is 2, echo that. Otherwise, this, and we have normal elif and else after that. When the when statement is almost the when statement is almost identical to the if statement, with some exceptions. Each condition expression has to be a constant expression of type Boolean. Okay, it absolutely has to be constant expression. It cannot do any checks that are runtime bound. The statements do not open a new scope. So this doesn't have a special scope, and that's very important. The statements that belong to the expression that evaluated to true are translated by the compiler. The other statements are not checked for semantics. However, each condition is checked for semantics. Okay. So the statement that belong to the expression that evaluated true are translated by the compiler. The others are ignored, basically. Okay. The when statement enables conditional compilation techniques as a special syntactic extension. The when construct is also available within object definitions. Ooh, I didn't know that. Ooh. So, we could do basically, this will be similar to why are they using elif for when statement instead of lwhen? Why? Because this way they can reuse the keyword and not make another reserved keyword that you are not allowed to use as a not use, you wouldn't be able to use lwhen as a variable name if that was a keyword, right? So the idea is to minimize it as much as possible. LEB314 says, yo, hey, how are you doing? Is it morning for you or is it night? So with the when, we could basically say when define windows. There you go. In Zig, when is called comp time if. Okay, I see, because Zig has this very explicit comp time thing, right? Yeah, so here you basically would have when, so we can make, const debug, right? Is false or whatever, so when debug, then we're gonna just make let constant debug prefix is this, right? And we can actually make normal var, because what we're defined here is just gonna get compile, so we can make it into a variable, right? So we just can make it into a debug buffer, okay? And that will be just new sequence of 100 strings for whatever reason. LB says it's 9 time. Okay, welcome to the US, I presume, or South America, or somewhere around, I presume. What brought you here? So, we can just compile some code. No problem. We can do whatever code we want to put here. It's just gonna check here. Else, we can, we don't have to do anything. Okay, we might just not have it available. So by now I can do something, if this happened or not, what not. And the thing is that, this is optional compilation, so you can write the rest of your code normally. That's fine. And I don't know how it is exactly in Zig, but with compiled stuff, you can do a lot in Nim as well. It just seems a bit less restrictive, I think. LB says, I'm just browsing the category, seeing who's here. Oh, we're reading the Nim language manual, and I'm trying to figure out how stuff works and how to kind of figure out how to use it. So yeah, that's that. So you're browsing coding category or Nim category? I would be surprised if that would be Nim category. Rarely anybody knows what the Nim language is coming here, I noticed. Okay, so we have that. So that means that we could just define type something like, I don't know. Let's say CPN, you said that you're writing a Tetris game, right? So let's call it a block. Tetris block, right? Which will be not enum, will be an object, because for some reason we want to just store it. You have, I don't know, number of blocks, right? Which will be an integer. And maybe for some reason, if you have debug enabled, you just want to do when debug. You want to also do string representation, okay? And that will be a string. And suddenly, when you have the debug enabled, you will be able to do stuff with that. And that one statement, you can put it here. You can put it probably, proc new Tetris block is this, and only when debug, include that code, okay? So you can imagine it. I would probably compare it to basically those pragmas, compilation pragmas or CPP pragmas or something. Yes, this is similar to an ifdef in C. I'd say 100%. That's what I was trying to refer to. Okay. LB says, I know of it, but I haven't looked into it at all. Yeah, it's an interesting world, I'd say. So when could be compared to the ifdef? The only thing is that, you can just do else if. Let's say else if something else, and else if, and basically have it a more readable way. And instead of having those weird pragmas that move your code around, this looks somewhat readable, right? This isn't ugly. And compared with combined with other templates and whatnot, it could be very interesting. And on top of that, you can just do additional stuff, right? You can do static, and this code in this block will just execute only during compilation time. Or you could define something as constant, and that means it's not only unchangeable, but it's evaluated during compilation time. So even if you have a procedure like, add this and that, right? This is, you can use it at runtime, but you can also say, hey, this is add this and that, and this will be basically evaluated during the runtime. And you can do a bunch more stuff. It gets complex. There are a bunch of examples of doing weird stuff, but I noticed with Nim, the nice thing is that it kind of stays readable, and I like it because of that. The other thing is that I can make this into a static int. That means that when I'm calling this function, the only parameter I can pass it here is the one that's known during compilation time. If you need that restriction for some reason, like another weird thing, like, to make it type static or something. Yeah. I started my journey with Nim in a way that, A, I did it 100% in a stream. B, I instantly thought that it would be like Go or something where I pick it up and wham, bam, gonna make a super cool package and be happy about it, which I need to get back to that first package I started working on. And it's just, let's say, coming from places like JavaScript, you want to make a lot of things that just happen magically. That, this automatically happened, that automatically happens. With JavaScript, you can make those fun little helpers that, make things magically work. You have no idea how it works behind the scenes. It's just invisible, but it works. And sometimes you can do those things partially in C#. And Nim just begs for doing those things because there's so many, fun features for metaprogramming and whatnot. And therefore, I'm instantly tempted to start using them. And I encounter very weird places and start scratching my head, especially when you start dealing with weird generics and yeah. But hey, generics is the main reason why I am not using Go. Because the generics sucks and I like powerful generics. Okay, so that's one statement, and I just learned that we can do this, which is awesome. That is so awesome. To have, partial object definitions. And then we have a very special case, when NimVM statement. NimVM is a special symbol that may be used as the expression of a when NimVM statement to differentiate the execution path between compile time and executable. For example, with a procedure, some prog that may run in compile time, okay? When NimVM, so this branch is taken at compile time, else this branch is taken in the executable. So instead of basically using when to define two separate procedures, or have two different procedures with different names, you can just have one and two different paths, right? Yeah, SPN says, if you're planning on looking into low-level languages in the future, consider Zig. I would definitely consider Zig. That's probably something I would enjoy the most if I decided to get back more into, programming microcontrollers, because that would be fun. Although I would probably consider Nim for that as well. Other than that, I would probably look at Odin from game perspective. But I don't think I want to go low level. Although there's one thing I would like to do at some point, but that could be considered low level. Yeah. I mean, I looked at Zig a few times. Just, peruse through the tutorials and few things around. It's just like not exactly what I'm looking for right now, but Zig is definitely, on my crosshairs. I don't really want to go in C direction, and low level, I don't really dig Rust. So I was learning it for a while, and just pure pain. Too restrictive. Just makes me not happy. So yeah, definitely Zig, or again, trying to do something crazy and go even less mainstream, which will be Odin. Yeah, but for a few times, I was thinking, you know what? It would be nice to make a computer game, which is, in my case, for me to think to make a multiplayer game is something weird, because I usually I'm not a person that's used to play multiplayer games. I literally have no friends, so I never had anybody to play with. Therefore, I'm not used to play multiplayer games. And but sometimes I have an idea that, you know what? It would be fun to make a multiplayer game. And one of those ideas is to make a game where 2 or more teams compete. And this will be like, the very team oriented. And a game would have several stages. Let's consider 2 stages. First stage is that the team has a spaceship that they can build from different parts, different blocks. You can imagine one of the common build systems for, various games. So many games now just, have some kind of build system. So you have a build system where you can make those ships, okay, from various walls and segments and whatnot. And inside all those walls, you can route your own pipes for water, pipes for steam, or for oxygen and whatnot. You can route them however you want. The same with cables, additional connections. And the whole idea is that in several, you can basically, you have for your spaceship, for a spaceship, there are a few, size categories, whatever, as it usually is. But there will be limits that in this category, you can't have, a size larger than this, or maybe the complexity of parts that you use, like, armored parts use up more of this, or maybe some technical parts use up too much tech points or whatever. And then on top of that, you would have something that would be, I don't know, computation points. Because in a game, you would be able to place little tiny devices that are programmable in some kind of specific language that then is executed. And those devices can control, that you have a keypad to open the door. Maybe you can hook them up to have a turret system automatically target the enemy ship. Or make some kind of fancy system that, if movement is detected here, sound alarm here, open that door, vent this thing, put this whole place under lockdown or something. You could program those things to make fun things. But the problem is, because the game would be A, multiplayer, B, it will be probably first person, and you want things to be fair. So you don't want to have a situation where somebody wrote code that, uses so much resources or something. That's why you have those complexity points. But basically both spaceships and the whole code would need to be run basically instruction, like low-level instruction after low-level instruction on a specific clock, so that, execution on both sides is always ensured to be correct, and it's way slower than, normal computer will run. This way, your code quality matters, and it could be an interesting challenge from a perspective of, having a game where each team basically takes care of their ship. They need to man it during, the second phase where maybe you need to board some other ship or you have a fight or whatever. And suddenly the other team needs to go through the other team's spaceship and try not to, try to get through booby traps or whatever. Other thing is, we found that in this wall here, in this exposed wall, they run a pipe. We just cut through there, hack into something, whatever. It's just, that's where I thought like, that would be probably an opportunity to write your own very small language that is probably something stack-based or whatever, that just have limited sets of instructions, and you can write them on the clock because they are like assembler or something. So that would be fun to kind of make a language. Okay. And the same thing is like, we have this, what is it? Let's go on YouTube. And let's search for micromouse. Sure, micromouse. It's like a robotics competition where, yeah, this is not sped up. Where basically you program little robots that need to go over a maze. It would be fun to make it like an online version of it where you submit your code in that specific language that is basically running on a simulated microcontroller. Therefore, it runs on a specific clock or whatever. Or I don't know, maybe WebAssembly or something. And just have those competitions of running code that's limited by different constraints. Yeah, for example, stack-based VM. Something like that. Something very simple. And yeah, I'm just thinking like it would be fun to make, again, like a virtual version of those competitions. But instead of making the maze normal blocks, it will be actually simulated with nice round edges, maybe actually 3D. And that could be a fun playground or competition for various, approaches of navigation stuff. I don't know. Another concept that sounds like kind of fun to make, where it wouldn't necessarily need to be, what would you call it? Wouldn't need to be multiplayer, but it would need to be deterministic. So the same code will always result in the same thing. And then I had an idea of something. Hey, how about maybe each person builds their own robot, programs them from different parts, and then they, fight autonomously during simulated battle or something. And another, kind of competition thing. All right, let's just get back to Nim, wherever I was, because I'm just thinking about crazy stuff that I really want to make, but it's really not that simple. Okay, so basically we can have those different execution paths, and then constant CT value, samproc, this would get executed during this part, while this will get executed during this part, because constant are executed during compilation time. That was a long tangent, lol. Yeah. Yep. I am very susceptible to going on the tangent. Sorry about that. I just can't stop talking sometimes. Probably all the time. But it's weird because day to day I'm like a quiet guy that doesn't say a word. All right. A when NVM statement must meet the following requirements. Its expression must always be NimVM. More complex expressions are not allowed. It must not contain elif branches and it must contain an else branch. Code in branches must not affect semantics of the code that follows the when NimVM statement. For example, it must not define symbols that are used in the following code. Okay, sure. So it's just execute code, but don't define any weird variables and whatnot. This is not equivalent of a normal when. Okay, this is just execution path rather than compilation of code. Okay. And then we have return statement. For example, return 40 plus 2. The return statement ends the execution of the current procedure. It is only allowed in procedures. If there is an expression, this is syntactic sugar for result equals expression, return result, right? You can just do return expression. Alrighty. Return without an expression is a short notation for return result. If the proc has a return type, the result variable is always the return value of the procedure. It is automatically declared by the compiler. as all variables, result is initialized to binary 0. So if we have proc return 0, an integer, and we wouldn't have anything here, it will just return 0 because that's the behind the scenes result variable that gets created for us. Very interesting concept, and I found it very useful many times. Yield statement. Yield 1, 2, 3. The yield statement is used instead of the return statement in iterators. It is only valid in iterators. Execution is returned to the body of the for loop that called the iterator. Yield does not end the iteration process, but the execution is passed back to the iterator if the next iteration starts. See the section about iterators for further information. We'll be definitely looking at them closely because iterators are very powerful. It's good to know how to use them. Block statement. For example, var found is false. Block, my block. We have for loop here, inside of which we have another for loop, inside of which we have if statement. So if found, we break my block. Okay, so this means leave the block, in this case, both for loops. This is something I like a lot, that you can just break to a specific point. I'm missing that a lot in some other languages, and this just makes skipping so much easier instead of adding extra checks here and there, and because of that, your performance in the loop degrades because of something else. It's just, this is nice. I mean, it's C# because you could theoretically use Go too, but that's kind of ugly. And sometimes breaks things like transactions. The block statement is a means to group statements to a named block. Inside the block, the break statement is allowed to leave the block immediately. A break statement can contain a name or surrounding block to specify which block is to be left. And I want to check how the first statement works in this case. I'm really curious. So we have this code, right? It goes from 0 to 3, then for another 0 to 3. And if... What is A? Where's A coming from? There's no A. So basically some array, if found, true. So let's basically make it if I times j is equal 6, found true, and bracket and echo found. Okay, let's try to run it. C# doesn't have block labels. Something like this, no. A C#, you just have for loop inside the for loop, and when you break the for loop. It can't break out. You would be able to define a label, my block, and just do go to my block, which works, but in some weird magical situation, you might break something. So you need to be careful of that. Yeah, I don't think I've seen block labels anywhere else, to be honest. Executed and returned true. Okay, sure. Great. But what if I want to do break my block? What if I did this? I did something like echo found exclamation mark. But every time I start this iteration of the loop, I'm just gonna do defer echo iteration this. I hope this is correct, Nim. It's not. I always forget how to print that out. There we go. So look at that. We do iteration 0, 1 to blah, 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 because this is deferred to the end of this iteration. So it will run after the if statement. And if we found, okay, then we're gonna printing that iteration again, because then we're exiting the if statement. We're exiting the iteration, therefore defer will trigger. Okay, there we go. And only then, when we exit the block, we run this here. Perfect. So the first statements work properly. A lot of languages I used has block labels. JavaScript, Go, Zig. JavaScript? I've never seen it in JavaScript. That would be interesting, because that could simplify some of my code. Show me an example of block labels and JavaScript. Huh. Oh, okay. Oh, that's what I see. That's what Svelte is trying to use. So we have outer, and we do this and that. And we can break to, oh, I didn't know that you can do that. That is so helpful. That is so very helpful. Does one need to immediately start a loop after starting a named block? Can I use it in some other way? You don't have to. How else could I do it? Okay, just my block and do this stuff, and at some point break it. Okay, I really like it. I had no idea that's available in JavaScript. That makes me very happy. That is so awesome. Thank you for pointing that out, CPN. I didn't know about that, and I guess I didn't go that far in Go in learning to learn about them, or I just went through them. But I'm just happy that Nim has that, because I just find it really cool, especially if it makes the defer and probably other fun features. Okay, back to the thingy. Today I'm somehow starting to enjoy the Nim Manual. I know it sounds crazy, but I'm starting to enjoy it now. So the block statement is a means to group statements, can contain names surrounding block to specify which block is to be left. Yeah. Then we have the break statement. The break statement is used to leave a block immediately. If symbol is given, it is the name of the closing block that is to be left. If it is absent, the innermost block is left. Can I do block Nim, right? And then break still like emoji of heart. What is it in cards? I don't remember. Come on. Must be somewhere. Not those, not those. Here. It's called red heart. Okay, there we go. And I can do break heart. And it should still compile, right? Yep. Okay. That's fun. Gotta love it. Okay. While statement. Example. Echo. Please tell me your password. And read line, and we have just while with condition. Do it forever until the condition is met. Wait, while password is not, so until this is false. The while statement is executed until the expression evaluates to false. Endless loops are no error. While statements open an implicit block so that they can be left with a break statement. Exactly. Continue statement. A continue statement leads to the immediate next iteration of the surrounding loop construct. It is only allowed within a loop. A continue statement is syntactic sugar for a nested block. Okay. Is equivalent to this. Okay. All right. I see. So let's say I have while loop inside of while loop or whatever. At that point, I just can't do continue in name of the block, which would be awesome to be honest. But I can always replace it with, my own version of it. Okay. Sure. You could even probably name it continue A or something. And just do break continue A or something. Assembler statement. The direct embedding of assembler code into Nim code is supported by the unsafe assembler statement. Identifiers in assembler code that refer to Nim identifiers shall be enclosed in a special character, which can be specified with a statement's pragmas. The default special character is the backtick. So push stack trace off and then pop it off this code, I guess. Procedure, add integer, A and B. And we just do assembler. And okay, A and B and all that stuff, raise overflow. And the GNU assembler, if the GNU assembler is used, quotes and new lines are inserted automatically. Bam. That doesn't look very readable, but I know nothing about GNU assembler. CPN says, I didn't know I'll be seeing assembly code here. Can I run it? Or is it gonna just break my computer? I had never run assembler code other than in Garry's Mod. Back then in Garry's Mod, there was something like electronics, whatever stuff where you could create little computer chips, and some of them you could program in C++ inside the game. Some other one were like graphics one where you could actually program them in assembler, which was nuts. So, echo this. Will that work? Nope. Execution of an external compiler program GCC failed. What is the problem? Assembler, too many memory references for mov. And for add. Too many memory references. Okay, these are errors I am not familiar with. This must be very system specific. And GNU assembler will be even crazier. Oof. Yep, that's a fun error. But collect to AC error. Yeah, nope. Ask AI a working assembly example. Oof. Oh, that's gonna be fun. You want to see working assembly code. All right. Please show me a working assembly code example that adds to numbers. My processor is, and let's find what my processor is exactly. There we go. Can I copy it? Yes. Okay, come on. Copy. Is this, and I'm running Windows 11 64-bit. Let's just start with the generic assembly code, right? Let's see what's gonna figure out. We'll use, okay, it's just that assembly, that's it. Wow, okay, that's a little bit more code. Okay, data. We just define bunch of numbers. Result 0, whatever. Even we have format like that. Wow, that's fancy. Main prologue push. Place this inside that. And we start playing with registers. Okay, so these are supposed to be variables. So take whatever input was to number 1. Then the B goes to here. Add this to that, and that, where does it get placed? Move, and the result. Huh. And there you go. And then prepare arguments, print F. Sure. Let's ignore the whole printing part. Now please, what do you call it? Make it work in Nim. The following is an example of how to use assembly in Nim. The example itself doesn't work on my computer. Okay, and let's see what the hell's gonna say. Let's just go to the manual and get the nice looking example, okay? Wait, I'm going to here. Let's plop it here. And let's see what it's gonna come up with. Use 64-bit registers and adjust assembly code accordingly. So add end assembler and move Q, and we have those. Move first argument to racks and blah blah blah. Jump overflow. Huh. Proc raise overflow. No return. Let's see what happens. Wait, here's the copy button. What is going to happen? Illegal operation. Hey, but it looks like compiled. 20. Because this will raise overflow exception. But this got 30. So if we're gonna do this, that should work. There you go, working assembly code. Thanks, AI. Okay. Give it some time and you can figure it out. That's awesome. Huh. So basically, whatever Q is, but move RCX is, I guess, the register something to the C to A. Then add the second argument. Oh, so this is like straight up add whatever we have in the next argument into this one. And is this ASM no stack frame? It added yet another interesting little thing that wasn't mentioned, right? Because that wasn't in the example here. Yeah. Huh, go figure. Yeah. Return. And we have separate, basically jump to here and bam. Call queue. This could be usable. I can see it being usable if you really want to do some low level stuff. Hey, why not? So looks like Nim is relatively easy to use assembler within it. And of course, it's stupidly simple to use C code in Nim. So, wow, you have plenty of options to go low level. I wonder how difficult it would be to use Zig code, because Zig doesn't compile to C explicitly, but it kind of goes through C. I don't know how it works exactly. I'm curious. Okay, so next we have the using statement. The using statement provides syntactic convenience in modules where the same parameter names and types are used over and over. So instead of doing proc foo, C context and node, and then this context and blah 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 blah. Just we have this and that repeated so many times. One can tell the compiler about the convention that a parameter of name C should default to type context and should default to node. So using C will be context and will be node and counter will be int. So we can just define procedures C that take C and counter, and compiler knows to just put it there. Oh, that's actually convenient. But so yeah, C is inferred, N is inferred, X and Y are of type int. What if I define my own things? Interesting. The using section uses the same indentation based grouping syntax as a var or let section. Okay. Note that using is not applied for template, since the untyped template parameters default to the type system untyped. Mixing parameters that should use the using declaration with parameters that are explicitly typed is possible and requires a semicolon between them. Okay, so I guess this is same parameter names. So this is specifically for defining procedures and nothing else. Huh. Okay. I would expect it to have a broader use, but maybe that's enough, right? I just wonder if suddenly normal variables would be using that, but I don't think so. So we had the if statement, but also we have an if expression. An if expression is almost like an if statement, but it's an expression. This feature is similar to Turner operator in other languages. So for example, we can do var y is if x larger than 8, 9, else this. An if expression always results in a value, so the else part is required. Elif parts are also allowed. So, yep. In one language, you'd have, var y is x 9, 10, right? To be honest, I kind of like the syntax of ternary, like classic Turner syntax, because often you can just do it like x and maybe this is 9 and this is this. And you can just kind of present it that way. Therefore, if you have something else here, right, you can still make it out, because you can see that, okay, I had this question, I have this and that. And if you really want to, you can just go on with indentation, right? And continue however you want. Gets ugly, but whatever. Well, here we have the whole if this, else that, which I believe we should be still able to do just that, right? Echo y. Will that work? No. And declare identifier x. Oh, let x is 5. There we go. I don't know, it works. Okay, so I can do that. Sure, it's this. Else it's that. Sure. I kind of like the ternary. I know, I'm weird. Zig takes this part a bit further. One can use switch statements, loop, or any block as an expression. Okay. So we can do let x is 1 to 3. Let y is case of x of this, else that, right? And echo y. So we should get 4, 5, 6. There we go. Can do that. How about we do for I in 1 to 10? We're gonna do that. What the hell is gonna be y? Error expression. Wait, what? Oh, is of type int and has to be used or discarded. Huh. So this is probably where it starts to break because this doesn't return. So we can't do that. We can't do that in for loop. But what you could do is say block. And let's do for a 0, a plus equals this, and we return a. And now it works. Try break x. No, break won't consume the value. Yeah, break won't consume. Break will only accept the label. But, you know, we can just define a block and it will evaluate whatever returned. We'll get assigned here. So, yeah, and I kind of see that it will be possible to kind of, okay, let's have a for loop. So let's return an array or something, right? Kind of makes sense. Could be fun. But, template. Collect. And let's say that we need to give it an expression. Sure, let's do an expression of something like this would be the code. Okay, it'll be untyped. And we're gonna return the t. Untyped. Array, no, a sequence of the type untyped, I think. I don't know, that's possible. And then we will basically do var x is this. Oh, we would need to also have the, I guess like this, that we have that the total, whatever, list. Or we don't even do that? Yeah, we just call it list. And their var list is a sequence of t. Gosh, what the hell am I doing? And then we do code, and then we do return the list. I don't think that's gonna work. I will need to say that this is a t, and this is a t, and that's it. And could I then do something like collect, let's call it list. Okay, and we just run this code and we just do list.add this thing. The only thing is needs Sure. I don't think it's gonna work. Cannot instantiate T because it doesn't know what a T is. Let's just screw the whole T. It's untyped. And this would be very unhappy. Yep. Never mind. I'm sure there's a way to define it. I'm just too dumb with templates. But yeah. An if expression always returns a value, so it needs the else at all times. Yep. Just like a ternary expression. You need the else. When expression. Just like an if expression, but corresponding to the when statement. Okay, so you can do when x is that. Okay, I see. So, sure. Interesting, huh? Case expression. The case expression is again very similar to the case statement. Okay. We just went through that example of that. Makes sense. As seen in the above example, the case expression can also introduce side effects. When multiple statements are given for a branch, Nim will use the last expression as the result value. Yeah, so we can echo and then return something. I missed one of your messages, CPN. Dang it, Zig isn't unique at all. Yeah, Zig doesn't have a lot of unique stuff. Not really. Zig is just a small number of features that keep spirit of C, but make it a little bit fresher and a little bit more pleasant to work with. That's how I view Zig. Doesn't have anything that is, very unique. It's just a pleasant, unique combination. Like most of languages, I don't think Nim introduces anything that's, groundbreaking on its own either. Even though you have so many features here that, it's just endless. But, nothing groundbreaking. Block expression. A block expression is almost like a block statement, but it is an expression that uses the last expression under the block as the value. It is similar to the statement list expression, but the statement list expression does not open a new block scope. Exactly. So unlike the statement list expression, this variable doesn't leak out. So that's nice. CPN says, I first started C and then tried Zig. That's why I have that kind of perspective. Yep, 100%. That's why, that's one of the reasons why I'm learning Nim. Because the more languages you learn, at least to some extent, the more perspective you start gaining. The more you start seeing like, oh, this is a little bit of that, this is a little bit of that. And you start looking at languages from totally different perspective. You look at them more from a perspective, oh, this takes a little bit from this here, this takes a little bit from there. It's a nice combination. Yeah. And you don't even need to often have to learn a specific language as much as just go through the few first tutorial, see what it feels like, see the feature set at some point. You'll be like, wow, okay, this is interesting. I wonder how this and that interacts. And it's fun. What's this last element? Second last element. Yeah, that's what it was. Okay. So A is, and you have Fibonacci coding here. Why not? Okay. Table constructor. A table constructor is a syntactic sugar for an array constructor. So we can say key 1 is value 1. Key 2, then we have key 3 is value 2. Is the same as create an array that has this tuple, then we have that tuple, and then we have that tuple. So basically like a lookup table. Okay. Makes sense. Oh, so this and that, those two keys take this value. All right, I see. Huh. The empty table can be written as this, in contrast to the empty set, which is just the brackets, which is thus another way to write the empty array constructor, which is this. This slightly unusual way of supporting tables has lots of advantages. The order of the key value pairs is preserved, thus it's easy to support ordered dictionaries with, for example, key value dot new ordered table. A table literal can be put into a const section, and the compiler can easily put it into the executables data section, just like it can for arrays and generated data section, like for arrays. And the generated data section requires a minimal amount of memory. Every table implementation is treated equally syntactically. Apart from the minimal syntactic sugar, the language core does not need to know about the tables at all. Yeah, so these are fun. Nice ways to quickly make a lookup table and just store the memory as a constant. Awesome. Wait, we did go out of that? No, we still have a little bit. So we'll have type conversion, this and that, and then there's this whole section about procedures. What time is it? I think we will pause after those, and procedures will be some other time. Probably not next week, because I would like to do something else. I'm kind of thinking maybe we could try to make something different with Nim. Maybe we could try to make a surreal DB client for Nim, because there is no such thing, and that could be fun. We would need to learn how to use WebSockets. We would need to probably learn how the networking side of Nim works. Very different kind of stuff. Okay, let's look at type conversions. Syntactically, a type conversion is like a procedure call, but a type name replaces the procedure name. A type conversion is always safe in the sense that a failure to convert a type to another results in an exception if it cannot be determined statically. Ordinary procs are often preferred over type conversions in Nim. For instance, the $symbol is the toString operator by convention, and toFloat and toInt can be used to convert from floating point to integer or vice versa. Type conversion can also be used to disambiguate overloaded routines. So if we have proc p that takes integer or one that takes a string, we can basically say let proc var is proc x string this and that. Wait, proc var is a procedure that takes a string. Oh, we can take p and convert it to this type. And that will ultimately select this one. Huh, that's a weird one. Why not? You could do that. You could do it that way. Oh, I see. So if I had the two of them of the same thing, right? But one is X, one is Y. And X and Y. I can say that this should be an int, but with the X, okay? And I'll just call it with 1, 2, 3. So this should call this one, I think. Let's run it. Got X. If I'll make this one Y. Oh, it still calls X. Okay, so this won't allow me to differentiate it as if I will be calling P Y is 1, 2, 3, right? Yeah. So that still doesn't work. We can't differentiate between those two when passing them somewhere. Okay. Since operations on unsigned numbers wrap around and are unchecked, so are type conversions to unsigned integers and between unsigned integers. The rationale for this is mostly better interoperability. Come on, I'm having starting the trouble to speak. Is better interoperability. Interoperability. What the heck? Interoperability. Is mostly better interoperability with the C programming language when algorithms are ported from C to Nim. Exception: values that are converted to an unsigned type at compile time are checked so that code like byte -1 does not compile. Yep, interoperability. Thank you. English is difficult at times. No matter how many years I speak it, it's still sometimes hard to pronounce things. Note, historically, the operations were unchecked and the conversions were sometimes checked, but starting with the revision 104 of this document and the language implementation, the conversions too are now always unchecked. Okay. Typecasts. Typecasts are a crude mechanism to interpret the bit pattern of an expression as if it would be of another type. Typecasts are only needed for low-level programming and are inherently unsafe. So I can basically force cast something as an integer, okay? The target type of a cast must be a concrete type. For instance, a target type that is a type class, which is not concrete, would be invalid. So we have type foo, which is int or float. If we try to cast it to foo, if something to foo will be like, sorry, can I cast to something that's this or that? All right. Typecasts should not be confused with type conversions. As mentioned in the prior section, unlike type conversions, a typecast cannot change the underlying bit pattern of the data being cast. Aside from that, the size of the target type may differ from the source type. Casting resembles type punning in other languages or C++ reinterpret cast and bitcast features. If the size of the target type is larger than the size of the source type, the remaining memory is zeroed. Oh, so something could happen. Oh. So let's try something weird. Let's say that I don't think this is gonna work. Let's say that we have an array, right? Let's do var. A is basically, let's get a sequence of 1, 2, 3. Or let's make it A is an array of 0 to 10 of int 8. Or let's just do byte. Okay, just bytes. And bytes 0, 1, 2, 3, sure. We have 10 bytes. That means I don't know if I'll be able to get something out of it. I mean, in theory, I should be able to just do let n is, what was it? Cast to an integer. the whole array, right? Can I do that? And echo n? Nope, type mismatch. Got array for this. Oh, yeah, because these are inclusive. Oh, we got a number. There we go. So we were able to convert it, and we got probably just the first 4. Because if I'll make it into this, it will be still working, right? Because it's just 4 bytes. 0, 2, 3. Okay, run. Oh no. Oh, because when we cast the integer, it was a 64. So let's do it this way. We're gonna make this the whole thing, but let's make it int 32. Okay. 9. So int 32, we have this number. So sure, 76 at the end. So I should be able to just get the first 4. And CPN says in C, it's kind of like star and star. Whoa, okay, that's nuts. I mean, you make it on the pointer and star. Yeah, because you can just prepend something in parentheses to kind of force convert it, I guess. Yeah. It's just those stars confuse the hell out of me. I haven't done anything with pointers in a long time. But yeah, we could do it that way, and we got the same number here. So it's literally just took the first four bytes. So in theory, we could just make this, right? And just make it like that. And then what do we call it? 0 is true. Let's just make a 31 true and a 30 false and a 29 true. Okay. So 101 should be what? 1 plus 4, 5. So this should be number 5. If 0 is the valid, if 0 is the first valid first character. Sure, let's see if that works. Oh no, we got 0. What? Isn't that supposed to be 32-bit unless booleans are not aligned properly? It says it's basically taking the pointer of the variable, changing the type of the pointer, and then dereferencing it. Okay, yep. This is roughly what we're doing here. Is just we're not operating with pointers at this moment, but we could do it with pointers as well. No problem. Yeah, I don't know. Can we take a pointer of like let a pointer is basically address of A. But I don't know if we need to convert it to something else. Because of course the Nim server thing doesn't work at all. Restart Nim suggest, please. And it's like, nope, I am not gonna do that. Okay, so echo a pointer. I mean, if I'll do this, I'm just gonna echo the value, right? Yeah, that's the value. But what if I'm gonna echo this? This shouldn't be value, this should be just a pointer. And yeah, I would need to basically cast it as integer or something. And this won't work. And in this case, it's int64 probably, right? And this should be just a pointer. So it'll be, yeah, this is the pointer. And then with a pointer, I could cast it to something else. I could cast it as PTR and 64, okay? Or the value itself, it would need to be as this. So I cast the pointer. So let to be n pointer. Okay. And then I can just do echo the value that it holds. And in this case, it's 0, because for some reason, setting those last bits just didn't make it work. And I'm not sure why, because we could see that it holds all the values in the end. And it's 32 of them. Something tells me it might be aligned in memory in a different way. Probably with whole byte per boolean rather than actual working thing. And therefore we have 1, 2, 3, 4. If I would make the fourth 0, 1, 2, 3, a third one, A3 to true, we're probably gonna get a value 1 now. No, now we got a different value. What? 7? No, 6? 0? Maybe they're the other way around. Oh, now we have 1. Okay, I see. While 1 will be 256? Yes. Okay, so each boolean in an array takes up 1 full byte instead of just a bit. Not fun. Oh well, that's how computers work. If we want variables of booleans like that, otherwise we will need to pack it with probably an array of, I don't know, bytes and try to make it work differently. But I don't like to play with that kind of stuff. So let's just get back to the manual. And what else can we do? We have typecasts, okay. The address operator. The address operator returns the address of an L value. If the type of the location is T, the address operator results in a type pointer to T. An address is always an untraced reference. Taking the address of an object that resides on the stack is unsafe, as the pointer may live longer than the object on the stack, and thus reference a non-existing object. One can get the address of variables. For easier interoperability, it sounds so bad. For easier interoperability with other compiled languages such as C, retrieving the address of a let variable, a parameter, or a for loop variable can be accomplished too. Okay, so let's say that we have variable t1 hello, and variable t2 is t1, so we just copied it. Okay, it's just a var, because this means copy the value. And t3 is of type pointer, and we just take a value of t2 and basically reassign it from a specific pointer to a generic pointer, because this suddenly is a pointer that doesn't store information about what type it refers to, while by default here you get the type that it refers to. Or it does not. Oh, it does not. That's why we did this whole thing. I see. Yeah, that's why we're doing this thing here. Okay. So we can do echo representation of address T2, which will be bam. Okay, that's how we could do it to debug it. Hey, show me the representation of this thing. Sure. Okay. So, reference. It's a reference. So basically this points to this. Huh. So I guess this is the length of a string? Possibly. Because C string, I think, uses the termination stuff. Don't remember now. So echo cast this will just print out the hello. The following line also works. Represent address T1, which is to a let instead of a var. Yep. But I think you can't get address of the constant, because they're compile time, and therefore constants exist in this separate memory block that's kind of protected, and Nim for some reason doesn't want you to get hold of it, because that means you would be able to suddenly modify this static block in the beginning of the program where all the data is stored, and I guess changing that could be dangerous. But too bad, because that's where fun begins, right? The unsafe address operator. The unsafe address operator is a deprecated alias of the address operator. Okay, so it's deprecated. Good to know. Okay, we finished with that. So that's good. That'll be it for Nim today. I'll probably just have a little bit of fun with the code I'm working on for SurrealDB. So if somebody wants to stay for an extra 15 minutes or something to deal with a completely different subject, you're welcome to stay. Okay, so I was mentioning earlier in the stream that I'm working on a little system for managing items, like inventory management, where we have an item table. And an item can have a name, we can specify it's a container or not that yet. If there's a total, if there's some kind of quantity to it or something. And this is automatically calculated right now. We have the universal quantity, which is like in the universal unit. So if I specify that the unit is kilograms, this will be stored automatically as grams, because grams are specified as the universal unit of weight. And some notes. And then we have, code for calculating quantity and some other events. So what I need to do now is actually come up with a way to not this. Let me just copy code from somewhere else quickly. Yeah, this will do. What did just happen? Come on, where's select? Copy, paste. There we go. So we have the idea of an item. An item can be located inside another item as long as it's marked as a container. Therefore, something like a bolt can be located 100 of them in this organizer and 40 of them in a workbench. Okay? Therefore, a total will be of 140. But I want to add a concept that there's something called a package of bolt set. And I have 5 of those packages inside a cabinet. Okay? And each of those bolt sets basically has 10 bolts, 20 washers, 10 nuts, and maybe 5 spring washers. And therefore, when the total number of bolts is calculated, it takes into account those. And what I know now is that it will be still item, but it will be is package true. Okay? That's the difference here. It's still just a normal item, but it has this new contains thing relation. So that's what I'm trying to do now. And I would just basically need to figure out how that would work. How would I query it? Okay, so maybe I'm just gonna define that contains, okay? Let's try to do that. So we can just go here. I had like initial draft of contains. Sure, it'll be from item to item, right? So let me just move this implementation up here. So now the new version of the database, I need to first do remove field. If exists, right? Whatever. If exists, n on table contains. Define field if not exists. Oops. So we've got this thingy, and here we have the out. SPN says, I don't want to sound like an old person, but I would it would be better to write the logic on a separate backend API. Kind of yes, kind of not. And the thing is that what I can do by writing logic here is that whatever I'm going to do is gonna all happen in one transaction. So I don't have to, because it's often happening that what I will be doing is I'm doing a bunch of lookups, or when I'm going, like, let's say I have a specific example. Let's say that I have an item, or maybe I'm gonna run a live query, okay? Let's say that I create an item called bolt, okay? It'll be bolt, it's not a container, false. I'm just gonna move that down. Can I make it larger? I can't make it larger anymore, I'm sorry. So I have an item bolt, okay? I'll say M3 20mm bolt, okay? And I'll measure them in a unit of how many I have them, of like whole bolts. So I'll create that item. Bam. Okay? So what happened now that I created that item? Well, let's look. So we'll look at item name. It just got created. Is container, I set it to false. So assert either its value false or something else. It was false, so it's good. Okay? Is package default false? Sure. Total. It's an object, and I define only unit inside that object. Okay? So the quantity defaulted to 0. Okay? Then I have a universal quantity, which defaulted to 0. I have total unit, which I specified to be unit X, which is basically how many of whole pieces I have. It just made sure that that unit actually exists. So that's already another query that I will need to do manually. Let's check if it exists. Sure, I could add it into the query, but this is nothing crazy yet, right? Basic logic, it's fine to have those basic checks. And then I have the note, which I didn't set, so that's fine. So that's what I run, right? So let me check that. Let's do select everything from item bolt. Run. Run here. So, okay, that's what we have, right? Nothing crazy happened. But let's just make sure, because suddenly I know that the event happened. I have on name change, on that stuff. So on unit change happened because there was no object, and now the object happened. I'm just making sure that the event is not delete. So create happened. Okay, that's one check. Before is not as new, and before was nothing. Now there is something. So what I'm doing is recalculating the item quantity. Okay, what it does, it basically checks if there are already some references. So maybe for creation doesn't matter much, right? On name change, okay, if it's update, so this didn't happen, so that didn't happen. So not much happened here. But what if I'm gonna make another item? I'm gonna make something like item bolt set. Okay, I'm gonna make it is container true, and it will be a set of M3 bolts. And I'm gonna run it. Have the same thing. So let's select the bolt set. And bam, look at that, quantity is 1. Universal quantity 1. So what it means that suddenly this whole recalculate item quantity decided that, you know what? This needs to be assigned 1. Why? Because if item is a container, and first it checks that if it's a container, it needs to be of the type X. Because you can have only one container that you can put stuff in. You can't have half a container. You can't have a kilogram of a container or anything. It's just that. Then it searches for links and whatnot. In this case, there are no links. So in this case, because it's a container, we're hard coding the quantity to 1 because we always have one container. We don't have to say where it is. It's just 1. Because if I define that I have a room office, I might not want to create a whole container. You always have that root container somewhere. And in my case, I just wanted to always be 1 and not allow any other number. If I have quantities, if I have a situation where there's larger than something, a container must have a quantity of 1 and not, for example, 2. Okay? I can run those checks. And what happens is those checks are running during the first transaction that I just created an item. If I would make an item that would have something else here, some invalid value, something that shouldn't happen, somewhere in this transaction there will be an error, and the transaction will get aborted. Therefore, even though I can make a lot of things happen, and they are transactional, so that's one thing. The other thing is that if I wouldn't have it all complex logic as one transaction, that means that in my code, I would need to do things like, okay, let me grab this part of data and that part of data, and suddenly maybe it's out of date or something, or I would need to manage some long living transactions that, basically force the whole database to halt because I'm doing a bunch of requests and waiting for network to return them. This way, if I can make it, the database do a bunch of this stuff for me, and if the code isn't complex, I'd call it a win, because data is as local as possible. All the checks, everything will run as fast as possible. And that also means that the goal of mine will be that I will basically have a set of functions defined on a database, and I'll be calling only those functions. I won't be running my own queries. Yeah, I mean, for most of our applications, I wouldn't go with this style. But in this case here, I wanted to make so that I'm running specific functions, as in stored procedures, like create item, unpack it, move it temporarily here. You know, few of the specific actions, so that I'll be able to make a nice web application for management that can focus purely on displaying data and making it easy to use, and utilizing those, smart functions that will make sure that everything is always integral, and therefore I can make mostly front-end app rather than dealing with a backend. And nothing stops me later from making, I don't know, a little Android app or something that can still reuse the same queries, even though it's in a different language. I have maximum code reuse. And the interesting part is that I can now say that I want to put that bolt in a bolt set, okay? Let's see what happens. I'm gonna do basically this thing, okay? So I'm gonna create a relation, link between them. It will be, where is it? It'll be equivalent of located in, okay? So relate item bolt is located in item bolt set. And I'll say that I have 25 of them here, okay? The unit is the same. And I'm just gonna run. Okay, we got created. New ID, I'm just gonna copy it for now, just so that I can refer to it. Item, whatnot, out is this, quantity is that, right? So let's get that bolt selected. Bam. Look at that. Quantity is automatically pre-calculated. The moment I committed that transaction, the part of that transaction was also making sure that all the quantities are up to date. Okay. What's gonna happen if I'm gonna select that specific, inspect that specific relation that I just created? What's gonna be inside there? Run. So we have item location, and this thing suddenly says that the location of the in item is item bolt set. Okay, nothing crazy, right? Location string, it it took the name of the box set that the things are in. That's fine. So what if I'm gonna make another relation? Let's say that this time I'm gonna put that bolt set inside something like, let's see, where did I have it? Let's say I'm gonna put it inside filing cabinet 2, drawer 1, okay? I'm gonna put it there. And I'm gonna say that, quantity, let's say I want to put 5 boxes in there, 5 bolt set, right? Run. Oh, sorry, found 5 for field quantity with record this, but field must conform to value is larger than 0, and if this is a container, it must be 1. So it already forces me, sorry, you can't do that. 1. Run. There we go, we created the relation. I will inspect it again, a new relation. And what it says, wait, did I just run everything like an idiot? Yes, I just run everything like an idiot. Let me just run just that part. Nothing should break. Okay. Now this location shows all that. So if I would just go undo and grab the first location that shows me where the bolt is, I can see that the bolt is inside the office, inside the file in the cabinet 2, inside the drawer 1, inside the set of box of M3 bolts. And all this is computed and verified during runtime. I mean, during one transaction through actually, what do you call them? Recursive events, which is kind of nuts that you can do that so easily as you can do it here. So the fun thing about it is now that, let's say, what the hell, the name of office is this. And I can quickly check what is inside that office. So let's say that I want to select basically everything that points at the office that's located in, right? And I want all the items that are in there. Okay, from item office. I want to see what are the things that are pointing at it. So inside the office, and this is a query that says the items that are directly in the office, not something that is somewhere else. All those items are here. All right, CPN. See you later then. Yeah, take care and have a great weekend, because I am not sure if I'm gonna stream this weekend. We'll see. It was nice to have you hanging out here. So now that I have all those items in here, including filing cabinet 1 or filing cabinet 2, in which I have a drawer number 1, in which I have the box, in which I have a bolt. If I'm gonna rename that office to just have with no exclamation mark, bam, and I'm gonna rerun that query to see what's inside that relation, the office already is recalculated. As long, also in all the other ones, in all the other items or like relations, I have recalculated where location is already accurate office. So this way I don't have to run any other crazy queries from my front end. Everything is up to date after every transactional change, which makes me very happy. See you. Okay, so now the goal is that I want to expand the system to have this whole something as a package. Excuse me. So considering this is a package, what could I do here? So let's just think about it. I'm going to copy this and simplify it just for the sake of working with it. Let's say that bolts is just bolts and washers, right? No nuts, no other stuff. Just that. Simple. 10 bolts per bolt set and 20 washers per bolt set. Okay? Just that. That means that I need to have the item washer defined, even though it isn't placed anywhere. The same thing with bolt. So let's define the washer, okay? Let's go here, and I'm just gonna get rid of all this stuff. I don't want it here, okay? Let's just work on this part. So we defined the bolt. Let's do washer. Is container? No. M3 washer. Bam. We have the washer, and when I query it, I am sure that, we don't have any. It's not located anywhere yet. So now what I could have here is create a bolt set. So we already have that bolt sets existing there. So the thing about bolt set is that at this point, when it's a package, it should not be a container. So maybe we should add a rule for our database already, specifying that if I'm gonna go to the item, we have on unit change. Where is it? All the way up here. Is package. Maybe we should also do assert that the value is either false, or if it's not false, this is container is also false. Make sure package is not a container, as the container is unique. Okay? By unique, I mean that there can be only one container. So that's that part. That means that now I can basically switch here. So we've got the washer, we've got the bolt set that we should update. So let's do update item bolt set. We will set the container to false. Oh, when we will set it to false, it's gonna freak out. Run. No, it worked. Ah, so look at that. I changed it from container to not container. And that means that now some of the relations are not working because I already have bolts inside the bolt set. Ah, look at that. So I better handle it. I'll switch it back to true the way it was, just so I can make sure that checks will happen properly. So let's do it that way. Yeah, I mean, that's a change on the item. That's what it is. Okay. So what do we have here? On name change, okay. Let's also do something like this. But I'm gonna make it on is container change. So what do we need to check? If we want to make something a container, we need to make sure that there's only one of that thing or none. Okay, that's the first thing. Well, if we want to change it from being a container to not being a container, that means that we have to make sure that this thing, that there's nothing inside. Okay. So event on is container change. So event will be update or create. We don't care about the create, and we don't care about delete, because delete will be handled differently. Okay, so we want basically the update. So if before is container and after, if before is container is not what is after. Okay, basically that's the whole idea here. If the is container changed, what do we do here? So if the container changed, so if after is container, if so if after is container, so basically if we want to make it a container, so when item becomes a container, must be at most in one location and quantity 1. Okay, that's the thing. So that's the first thing that we can check. Okay, so let's say links. Let links is, and we're gonna select some stuff, right? So we're gonna take in parentheses, sure. Do we need to call select here? I don't think we need to call the whole select here. We can just take the item itself, which will be after.id, located in. Okay, this should give us the array of those links inside here. Although everywhere we are using that, so maybe I should be. Yeah, I'll be finishing in 10 minutes. So let's maybe just finish that part. So after ID is located, so let's do select, and we're just gonna do whatever's located in from only after. Okay, we take the after and we find its where it's located. Do we return it as a value? I mean, what are we returning here? Only will make it that, and this will return an array or like something located in, so we want the value. Sure. Only, I mean, limit 1. Okay, this should give us just the array of those links. Okay, so let's say parent links. So if array length of parent links is larger than 1, so if there's more than 1, can't make item, and we're gonna basically add it. String will be after.id. Can make this item into container. Has, and we can basically say how many parents. I mean, it's in locations, okay? And let's just use normal quotations here everywhere. Okay. So this way we can say basically in how many location it is. We cannot create it. So first of all, must be in only in max 1 location. Second is type must be item. So we can actually make it one of the first checks. If after type isn't, I mean, after the total dot unit isn't unit X, can make item in the container. Unit must be item. Okay, it's another check. What else? Type must be item, must be in 1 location. Do we have anything else? If it's a container, it cannot be a package. Can't be a package. So if it's a package, we can make it. That's it. Must be in 1 location. And the last thing is locations. I mean, total must be 1 or 0. Nothing between. Nothing else. Okay, so that's another thing that we can do before we start fetching the links. This way we can, improve performance on failures. So if total quantity is not 1 and it's not 0, total must be 0 or 1. Okay. There we go. This way we have a bunch of checks that prevent us from marking something as a container. Let me just check if there's anything else about it. Is containers package, total, quantity, unit, note. Okay, that should be it. That should be it. Sure. So, first of all, what do we change here? Let me just check because I should have code checked in. Item. Okay, we need to update this package. So we're gonna update that field quickly here. Let's just do this. Remove field is package on table item, and then we define it again. Okay. Bam. There we go. So we've got this defined, and this event here is brand new. Okay. So wait, we just covered only the if it becomes a container, but we need to do it the other way around if it stops being container. So else when item stops being a container. Okay. What do we need to check? If it stops being a container, we need to make it empty, right? So nothing can lead to it. So let's do contained links. Okay, so it will be the other direction. Whatever is pointing at the container that it's in. We got this, and this would be that. So if there's more than one, can make item can decontainerize item this. There are items in it. Sure, just items, okay? We don't care about the counts. They're just links pointing at it, okay? So if it's a container, okay? There's nothing else inside of it. Yeah, we can easily make it into another container anymore because it's still 1 or 0 or something. It can be suddenly in multiple places. We don't care if it's a package or not. So yeah, that should be it. I hope so. So basically, there can't be any contained items. Okay, that's it. So let's grab this guy and define the event. Let's see if we have any syntax errors. Oh, no syntax errors. Wow. I am impressed. Okie dokie. So does it mean that suddenly I can, if I'll try to make this not a container, it should stop me. Run. Cannot perform addition of can't decontainerize. Oops. Oopsie. Wait, what am I doing here? How are we adding it? Add this, add that, add that. Oh, there we go. This needs to be converted into a string as well. And that should be it. So we can just remove the event and define it again. Boop. And we set it to false. No, can't containerize item. There are 1 items in it, and that item is the bolt. So what we can do is basically remove that thing, which is this one. So let's just do this. Delete this specific thing, run, and now I should be able to run this query to decontainerize it. There we go. It's not a container anymore. That's awesome. Okay, and bolts are not anywhere either. We have 0 bolts now. So if that's the case, what can we do about it? Let me actually commit those changes, because I'll need to finish in a second. Come on. Where is it? Here. So contains I'm ignoring right now. What I want is the item. We added this for the is packaged and this fancy little event. And here I'm just leaving the way it was. The same thing here. Yeah, I just moved it up and that's it. So let's make it add protections when changing is container. Okay, that's all that matters here. Bam. Okay. Okay, so if that's the case, so what were we doing? We needed the item bolt set. There's nothing in it now, okay? So that's good. And we can mark it as is package now, right? Let's see if we can do that. So bolt set, and let's do is package true. Bam. There we go. It's a package now. So now we need to finish containing this, the contains. So we have the idea of items and quantities that are contained within a specific package. We have that it leads from item to an item. And the from needs to be a package, okay? And I'll also make that the out, whatever comes out, is not itself, okay? Because I don't want the whole thing to be in a way that something is itself. What it points out needs to be this and exist, and value dot is container. Basically it can't be container because a container shouldn't be contained inside a package that could be created multiple times. And basically don't point at itself. Okay, so that makes sense. Quantity will be some decimal value. Let me just see how I define quantity in here, because let's see. Assert value is larger than 0. And if this is a container, then value is this or that. So we don't need to worry about that because there is no way that what it's pointing at is a container. Okay. That's that part. We can skip that part. Good. And unit is basically this, and the category needs to be exactly the same as really, does it? So with units, how could we define it? Because we're not, this thing here is like, make sure the unit is in the same category as the items unit. But when we have the item set that contains something, you could have a set that contains maybe 5 of something and 2 kilograms of something else, right? So whatever is being contained could be any kind of any unit. So we shouldn't worry about it. And defaults to this, I don't want it to default to anything. Okay. Okay, let's get rid of the little period and stuff. Okay, just make sure that the unit exists. And then we have this, so we just make sure that a specific package can point to an item only once. So that's that. Location, we don't care about that because it's already within the package itself. Location strings, nope. Unique part, okay, that's it. That's all we need for a contain. Contains. So let's see if we can plop it here. I'm maybe gonna just do it one by one. Good. 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 How do we look at it? Contains. In and out. All right. Quantity. Unit. And the index. Okay, everything went through properly. So we have proper contains. Good. So I could say now that relate item bolt set contains item bolt. And here I would basically need to specify what? I need to specify quantity, unit, and that's it. So quantity will be 10 bolts. Unit will be, that man is, whole bolts, right? Do we have any restrictions now that when I create that something contains something, when wouldn't I be able to do it? Because we already have that, okay, this must not point at a container, must point from something that is a package, not multiple times, not at itself. I mean, the thing that would be nice to take care of at some point. I know, because I'm thinking like, can I have something that basically becomes a circle? And the thing is, no, I don't think so. Where is it? Because let's just take those two, right? I have this. Is package true? If this points at something, contains, it's just that. Okay, nothing else. And if this wants to contain something else, it needs to be is package. True. Oh, I can point at a different package. Okay, that makes sense. I can point at a different package, and that could point at this package, and that could point at this package. Therefore, this package contains itself, which kind of sucks. With those, I was able to manage properly because I need to update what's inside and what not when I'm recalculating all the numbers. but I'm basically tracking a list of what's and what not. I wonder if I should make it maybe not allow something to point at a different package. Because what I was thinking is like, what if something, like a package contains a nice organizer with that much of that bolt, that much of that bolt, and yet that much of that bolt. It seems like something that could be very useful. So yeah, I'll need to think it through to find a good solution for it. In theory, I can basically run through some of those iterations and make a limit on how deep you can go to not make, something crazy, within reason, maybe just 10 layers deep and that's it. And yeah, it sounds like a good idea. Something probably relatively simple to achieve. So yeah, we'll see. For now, I'll be finishing now. I want to thank everyone for watching. If you enjoy the content, consider subscribing on YouTube, consider liking on YouTube. If you're watching on Twitch, consider following me on Twitch. And I'll see you probably on Monday when we'll be doing some more game development. We'll probably continue with the little funny frog game that we made in Raylib to make it look better and actually add the kicking and make it playable. All right. So again, thank you for watching and see you around.